Okay, so hello everyone, and welcome to another amazing Cube Simplifier workshop. Hope you all are doing good. Please introduce yourself in the chats where you're joining in from, and you're excited to learn. So my name is Saiyam and I'm a CNCF ambassador working as director of technical evangelism at CIVO. And this set of workshops, this particular workshop is part of the series that we have been doing called Cube Simplify workshops. So we have started from Linux and Docker from scratch. We went to Kubernetes, we went to container and Kubernetes security, chaos engineering, service mesh, and even Kubernetes troubleshooting. And now today we'll be covering a different domain, which is Kubernetes observability, which is again super important for any application, any infrastructure, even Kubernetes. So monitoring observability is something which is very critical when you are learning something, and you should be knowing about that, and we got the best for you. So today I'm joined by Michael Friedrich from GitLab, who will be telling us about Kubernetes observability. He has been preparing this workshop, tweeting about that, all the preparations that have been going on, and we have loved those tweets as well. So make sure to share this particular stream in your network right away. Do it just right now so that maximum people can join in and they can take full benefit from it. Again, the prerequisites are very simple. You need to go through the previous workshops, or just you should have at least the understanding of Kubernetes. So you should be knowing, what a pod is, deployment is, what the Kubernetes architecture is, and stuff like that. So you should be knowing about Kubernetes, and you should be able to follow what Michael has in store for you today. And please be respectful to each other in the chat. That is very important. We are all here to learn. So please make sure you are just asking the right questions. I mean, you can ask questions related to Kubernetes monitoring, observability, but just don't be disrespectful. There are people in the chat who are Cube Simplify ambassadors who are monitoring the chat, also there to help you out. Now, if you have a larger question, like if you have something not working and you want to post pictures and stuff like that, you won't be able to do that on YouTube chat. So it's better if you can join the scrolling link, which is there, kubesimplify.com/discord, and there is a channel called workshops. So there also Cube Simplify ambassadors are there to help you out during the workshops and even after the workshop. So you should be able to like ask anything if you are stuck somewhere, and you should be able to follow along. Another prerequisite that was sent in the email who registered for this workshop was given by Michael. Like, you should be having a Kubernetes cluster, so that you can work with it. Now you can use Killer Coda, but we won't be specifically telling how to do things with Killer Coda. So if you have attended the past workshops, you already know how to use it, like exposing stuff, the node port services, how to access that and all that stuff. So you will be have to taking care of all those things. But all in all, Michael has done his level best to explain it from step by step, level by level, and you will have a lot of fun learning this particular workshop. Just one request is, stay till the end of the workshop so that you can say that you have learned a good amount of Kubernetes observability and you are ready to apply that knowledge in your current systems, because that is our goal. You should be able to learn something out from today's workshop and apply that knowledge in your systems, in your current production system, or as a POC, or as a personal project anywhere. So thank you so much for joining in. Michael, can you please introduce yourself to the community? And meanwhile, I'll bring all of the hellos on the screen.
I will definitely do that with pleasure. So my name is Michael. I go as DNS Michi, which is DNS MICHI on the internet. It's like the lovely version of Michael, but I figured it doesn't work in English that good. I've been with GitLab for 2.5 years now as a senior developer evangelist. And in my previous life, I was an open source monitoring maintainer. So I got to know quite a lot around what is monitoring, the shift to observability, and many, many other things. I'm currently living in Germany, in the Nuremberg area. My origin is Austria. So I moved there like 10 years ago for my passion for open source. And I'm super motivated to like share everything in for free so that everyone can contribute. This is also a motto, or not only a motto, it's lived at GitLab as well. And I'm super happy to be joining you today with like a free workshop. So it's not gated, it's not like paid subscription thing. But I really want to provide you the best way to get started. It's for free. You can rewatch everything later on if I'm talking too fast, or you just tell the folks in the chat that I'm talking too fast and they can slow me down. I'm looking forward to get started. Is there anything we need to like chat about before we dive in?
No, so just we are getting started. So make sure to I always forget this particular portion, which is very important. So make sure to subscribe to the channel, like this video, and press the bell icon so that you never miss a notification. And always follow Cube Simplify for the awesome updates. All the awesome workshops that we are conducting, so that you can get all the benefit out there. Your learning resources should not stop you from getting jobs, learning new things, and stuff like that. And like Michael said, Cube Simplify aims to simplify cloud native, and we always love bringing free content to you all, which is not gated at all. So just hang in there. It's all Michael's show now, and he'll be teaching us Kubernetes observability. Let's learn now.
Perfect. So the slides are now publicly available, and I would encourage or ask Saiyam to share them in the YouTube chat so you can like follow along. This slide deck has quite a few exercises and slides as we move on, so don't feel stressed about to like really understand everything or click on all the links which are required. It's just really, it should be a learning resource for you all. And there is also like a repository, a project being linked. We will dive into this in a bit. And you can also follow me on Twitter and LinkedIn and GitLab and Polywork and everywhere else. This is just me, but like to move on, what to like expect in the next 1 or 2 hours, maybe a little more than that. We will be doing a short introduction into like what is needed for this workshop. Then diving into monitoring, where it is, where it was, how we can like build something with Prometheus, Grafana, and Kubernetes. Further down the road, there is always like how to deal with alerts, incidents, service level objectives, and then going to the overall question, like what is observability and how does like tracing logs and even more add to that. And since there is so much to learn, I added even more ideas to the agenda for today, which is like scaling observability, scaling monitoring, what is eBPF, like a short introduction, a little bit about security as well, and then a lot of ideas. But don't feel overwhelmed. It's just like me providing you or trying to provide you the best experience and the best learning resources you can get out there. The requirements for the workshops, well, Saiyam already shared it. You should have a Kubernetes cluster running. This can be like Minikube on local host. This can be some in a cloud provider, and it's helpful to have some sort of experience. This is not required. It's just like me sharing an idea of having like you're coming maybe from the ops admin side and you know how to run and maintain services and applications. On the other side, it can be helpful to know you're a developer, you know how to write code, you're learning it, and you want to learn about like application limits or resource limits for your application, because like resources are not endless. And from a security perspective, it can also help to know like what is a potential vulnerability, about exploits and other things. So everything plays into observability and also Kubernetes. We will be working with a project I've prepared with the exercises and solutions. So if you're feeling stuck around the way, or there is like if I'm like copy pasting too fast in the terminal, it's always time to look into this project. There are the YAML files and the solutions basically prepared, which we will be using, and there are also some other projects which will be deployed. Everything is open source, so you can like inspect the source code and the deployments and learn from that by yourself, or maybe even like use the demos for your own blog posts you will be writing in the future, or deployments and so on. Yeah, the Kubernetes cluster is again described here. So for everyone who might be watching this workshop later on as a recording, there are many resources out there to get you started with a fresh Kubernetes cluster. I will be using one in Sivo Cloud. I told Saiyam that's the easiest way for me to do it after trying Killer Coda and figuring out I really want to like use a production-ready empty Kubernetes cluster for this workshop. When you start with the workshop, or when we dive into the exercises now, you can actively do the exercises as I go along. I'm trying to wait a bit after the exercises to really verify that everyone is ready. But unfortunately, I cannot see your faces like in a traditional in-person workshop. So if there is like the need to come back later on and re-practice the exercise or redo something, you can do that at your own pace. So you can watch me do the exercises or try to replicate everything as we go along. Those slides which require action have like the exercise colon prefix or discussion colon prefix, so that you know when action is actually needed. I've also marked some exercises as advanced because they require more knowledge and they might be moving too fast. So in a specific sense, just watch, listen, learn, iterate later on, and try it yourself. When we move along in the workshop, it can also be helpful, like taking notes in an online IDE, in your local IDE. I found it the easiest to just edit a README-MD with Markdown while doing the exercises. And you will also find many links in the slides, which you can also then study later on as an async exercise. Regarding Kubernetes monitoring observability, this is a huge topic. So Kubernetes on its own is a huge topic to learn. And I, for myself, felt very overwhelmed when I started, and my advice is don't feel that way. Try to find like smaller buildings, like brick by brick, building Lego, like in my background. Do small iterations. Also, technology is moving so fast. Really like focus on the basics. What is running in my cluster? How can I monitor it? We might be Googling together in this session. I don't know yet, but I'm also not an expert. And sometimes my tab history makes the memory of my browser explode. And I would also encourage you to ask questions and share thoughts in the chat. We will be trying to answer everything live here, I think, at some point. But also, like, my social handles. Please tag me in public for your questions. Maybe we even meet at KubeCon or community events in the future to do some exchange in person as well. Would be lovely. Now, this is more theoretical entry into the workshop, looking a little bit around like what is monitoring, where is the current path towards monitoring. Like monitoring in a nutshell, and probably it's not exactly a nutshell, but there are different types of monitoring. So you can monitor it, the heart rate. You can monitor different things for IT infrastructure. We do have monitoring, like server monitoring, network hardware monitoring. There are certain ways of application performance monitoring. We got cloud resources over the past 10 years, something like that. There are APIs, there are serverless workloads or functions, which can also be a way to monitor things. And we also got to use distributed microservices, and like maintaining or orchestrating containers became a cluster thing. And this became, for example, Kubernetes, but also other services which need to be taken into account when thinking about how can I monitor this, for what is the actual health status of this entire thing, of a specific service, and so on. Now, one of the things to keep in mind is when talking about monitoring, you want it to be reachable over the network. So something needs to be pinged or queried using a different protocol, be it TCP, HTTP, SNMP, or something like that. So these are like terms and things you probably encounter in the wild when you look at monitoring. Now, in the beginning, and this is like turning back time 20 years ago, like when Nagios was a thing, we had so-called black box monitoring. So it's like service attached to a host. There is a specific relation. You want to monitor a website and a specific external ping to see whether it works or not. And the idea is really you want to catch it before the customer calls you that they cannot shop, like they cannot buy anything in your shop because everything is broken. And this could be, for example, a competitive disadvantage because your shop doesn't work, but the competitor's shop works and everyone buys there and says, well, not coming back to you. So the thing is, monitoring things like you have an executable check script to deploy the services. You do that in a specific interval. And with like tools like Nagios, we had the thing like calculating a state. So you had either okay or not okay, some text output telling you what is going on. But how to like interpret things like these. So what is like the value of telling me, well, the response time of the website is 5 seconds. What exactly is like, is this a problem? Could this be like a trend? So you see something go up. And it's also black box monitoring. So you don't really can look into the application itself. So what happens inside? Why is it slow? And so on. These are all things to keep in mind. Now, if we think about what we want to look inside the application. So maybe the application has logs. A log could be a line which starts with a timestamp and then some context what is going on. So like the application is starting, the request is starting, and so on. This typically grows a lot. So at a certain point, you might be thinking about central log management. And then challenges begin like data retention, search performance. You need a query language. You need to think about many other things. And during an incident, it would be awesome if the monitoring system with the states is directly linked somehow to the logs, so you can see that the outage of the web shop is actually tied to some out-of-memory kills, which are only in the logs. Hopefully, there are logs. And the other thing which is like challenging is when you have added logs to the application or your development teams have added them, they also need to be passed by machines to store them. And maybe structured logging is a better alternative, but still requires teams to really adopt and learn what is structured logging in a JSON format, for example. When we move monitoring to like, hey, we want to see something, what is a trend or what is like a metric, when we have been polling services, in Nagios, it was called performance data, which is like then a metric value, which can provide insights when storing it over time. So you get to see that the website response is 1 second, and it's 5 seconds, and it goes back to 2 seconds or something like that. And this can be visualized within a graph, and it would be awesome to really calculate a trend for that. In the past years, there were like tools like RRD tool, Graphite, InfluxDB, which stored these time series. So it's like a TSDB, a time series database. But oftentimes it's really like when the monitoring engine that collects something was blocked, you had gaps in the metric graphs, and then also a scaling problem with like, would I be needing the metrics or the values for 5 minutes granularity, or do I want to have real-time monitoring, which is like 10 seconds or 1 second or 1 nanosecond or something like that? So there were certain challenges with metrics and trends, also with like classically monitoring. And the other thing which came around was since Kubernetes and container clusters were a thing, like the classical host service relationship doesn't really work anymore. So there isn't like a state of okay or warning or critical for a container cluster or for a service running in there. With metrics, we have the advantage of like just having values, names, and tags to being able to see something in a group. And the other thing which I've seen in the wild is if you have like a static configuration for host and service names, it doesn't really work with volatile container names. You start a pod, you potentially it fails, then it restarts itself. And with like microservices and distributed systems, you really need a new approach for that. And last thing around like monitoring, shifting towards the future or making a change was from the state black box monitoring and also service level availability reporting, like the state changes over times and also the metric data points. We are moving towards so-called whitebox monitoring, or have been moving in the past, which potentially was the first inception with Prometheus adding a /metrics HTTP endpoint into Docker as a container engine in 2016. So it's like 6 years ago already. This was one of the first visible things where you could look inside the application, and developers created their own metrics available for users to really being useful in deployments. Now, if we think of Kubernetes and container clusters and how does this fit into everything, like Kubernetes up and running requires quite some, like, I would say, knowledge. There are so many things to understand, and also like to understand when something is broken, how to like get to it. So I've just added a few thoughts and things like the architecture is important, the components might be important. You have nodes, pods, containers. You have deployment services and many other things. And then it comes to APIs, ports, data sources. And I know that that the previous workshop around Kubernetes troubleshooting was already awesome, or is awesome, which is a great way to really troubleshoot things. But it's also like the same for monitoring. So someone says, well, we need monitoring. Yeah, what kind of monitoring for Kubernetes? Maybe availability monitoring, or is it about performance and resources? Maybe we want to identify slow or blocking deployments somehow. So what is like the important thing we really want to know? As said before, like host service state-based with microservice doesn't work. So we want metrics, we want logs. Do we want something else? Is it necessary to understand all the components? Hopefully not. What are the best practices? So it's really like a lot to understand, and we need to focus on certain things. So like a microservice in a container can run anywhere in the cluster. It's no like you don't have a hostname or IP address which you can immediately access at a certain point. If we're defining replica sets, you can define the service being run on multiple pods. So there is no guarantee whether it says, well, 2 out of 3 are working, the service is okay or not okay. So-called classically business process models don't really work with that pattern. Kubernetes also detects health and repair state. So if you kill a pod, for example, it comes up again. And if there are certain like things broken in the Kubernetes cluster, this might be considered flapping. So something goes up, down, and traditional monitoring systems declare that as a flapping service and send you notifications for that, which is also not a behavior we want to replicate with that. And the other thing is like states are different in Kubernetes. So something like okay, warning critical doesn't really apply. And the other thing to note is, or to mention, metrics and logs are like highly dynamic. So there is a lot going on, and you really need to be capable of seeing what is important to you and manage all the data. Now, the first thing you can do and should be doing is like open the monitoring, logging, and debugging docs for the application. So this is not really tied to Kubernetes on its own, but any application you want to monitor. So like what could be the entry point to see when something is broken? So, or how can I inspect like when a node is going down, what is how can I get an idea how to monitor, for example, services which are being deployed? What is the description in the troubleshooting documentation, for example, when you go over resources? And then you get an idea about, hey, this is something I can apply to my own monitoring metrics and thresholds and other things. So this this goes even beyond, like, we can correlate cluster events and anything beyond that. So I couldn't really like figure out my own use case for Kubernetes many years ago, and so I was like, hey, maybe I should just deploy an application and try to monitor it, and then I can learn more about Kubernetes on its own. So for just like looking into this section, we can get quite an idea around debugging pods, debugging services, for example. So what are like the commands which are needed? This is helpful to really like dive into action when actually an incident occurs, but also like what is described within this section regarding things we really want to monitor, for example, the node health or something like that. Now, in order to like play around with that and get an idea is to say, want to change quickly into the terminal and promise we will be using the terminal in this workshop mainly for installing things and just to get an idea what is going on in the beginning. So like I don't have anything in this cluster yet. It was just previously deployed like 2 hours ago. And for example, I do have the K alias also installed, but I really want to show you the full version. I do have 3 nodes deployed, and type today. We also want to see the pods which are being deployed, for example. Now this provides some idea, and in order to inspect the logs manually, which can be helpful with troubleshooting and getting to know things, we can, for example, also say kubectl logs. Now I need to cheat a little. Deployment for DNS deployment, and this is in the kube system namespace. So it has been running for a while and has some warnings being deployed. Okay, this is quite a lot. But yeah, this can be like an idea to get to know what is actually currently like being deployed and going on in my Kubernetes cluster. Since this is like a fresh Kubernetes cluster, there are no deployments of my own. Nothing in there. But we want to like, we're getting to it. First things first, I've shared some ideas around like metrics, collecting values over time, and being able to calculate or to aggregate them, calculate certain things, get on with trends. And one of the things is like Prometheus. So we have in Kubernetes many different data sources. We might be using service discovery, which is a great idea. And within the Cloud Native Computing Foundation ecosystem or community, there's a great project called Prometheus, which is, we will dive into the architecture in a little bit, but the main idea is it collects metrics from a /metrics HTTP endpoint provided by applications, provided by Kubernetes components, and is able to store that in a time series database on its own. It doesn't need by default anything external. We can look at trends, dashboards. We can define alerts and service level objectives. We will be explaining or looking into that in a little bit, and have that available for incidents as well. Now, the idea is really like collecting everything, but also provide client libraries which allow to instrument your own code and provide the /metrics endpoint in your applications so that you can monitor your own applications deployed in Kubernetes with Prometheus. We will be looking into an example how this works also in this workshop. The other thing is like a Kubernetes cluster has many like volatile things going around. So there is like container environment, and we really need service discovery, because if something comes up like new, we really want to like add it automatically or have it available to being just approved or configured, and then it's visible in the monitoring and observability dashboards. The other thing which I really like about Prometheus is it's open source and it has an awesome community, but it also provides a query language which is called PromQL, where you can create your own queries, calculations, and provide that like as a raw data or within a graph. And as mentioned before, it has its own time series database as a backend. There are other things around scaling and long-term storage, which we will be tackling in a little bit. But just like for the architecture, how it Prometheus fits into the picture with Kubernetes, as well as you have the Prometheus server where everything like runs together in it. We have service discovery, which works with Kubernetes with different other service discovery mechanisms, like if you would be running console or some other toolings which provide discovery capabilities, you can also use that with Prometheus. So Prometheus works very good in my experience with Kubernetes, but it's not exclusively tied to Kubernetes. So could also like install Prometheus on your Raspberry Pi and monitor the temperature sensors for humidity and something else, for example, or do traditional infrastructure monitoring. Now, the idea with like Prometheus is you either get the metrics from jobs and exporters. There's also a push gateway for short-lived jobs. And when it comes to alerting, there is a component or a service called Alert Manager, which we will also be trying out later on, so that we get alerted from matching a certain threshold or certain violation of our conditions of being healthy. And we can act upon things and don't need to like look at a dashboard and say, oh, this could be broken. We might be looking into a fix now, but instead getting actively alerted. Yeah, and for PromQL, there's the Prometheus Web UI, and also later on Grafana and other ways to visualize things. Now, PromQL, this is something which we will be using throughout the workshop a little bit. It makes sense to remember how to, for example, define a range with the square brackets for the metric name to query, or how to like apply labels with a different type of, I think it's called angel brackets. But yeah, in the end, it's the different one to the square brackets. And this is like me lost in translation. But in the end, it's really important to remember that, but also like have the cheat sheet for PromQL open, which are also linked at the bottom, and also how to define functions which allow to, for example, calculate a rate over time, calculate a summary, or maybe even a delta, and also do comparisons, which is later on important to say, hey, if the metric, if, for example, the memory consumption goes over a defined value, this condition is rendered true, and therefore I'm sending an alert, or I'm showing an annotation within the graph that something is broken. Yeah, lots of theory. We will soon dive into action. Before we do that, there are different UIs available for Prometheus. So the web UI itself can be used for testing the script targets, so things we want to monitor in the future. We can query the metrics, and we can also like create simple graphs. For dashboarding, we will be using Grafana in this workshop. So you can define Prometheus as a data source, the time series database in Grafana, And also Grafana understands PromQL, so provides some like additional auto completion and query helpers, which makes it more convenient to like really build something and later on automate it and other things. And it also allows you to create panels and dashboards and save that and share that. Another project which is currently in development is called Perses. Not sure if the name will be like persistent when it gets released, but this is like the idea of providing dashboards as a code, certain like GitOps patterns inside. And it's currently in development. So if you're interested in like following this along or maybe even contributing, I would recommend checking out the linked GitHub repository in there. Yeah, last but not least, around terminology, service discovery kind of works with using a script config for a dynamic list of targets, or it's built in. So like Kubernetes service discovery is built in, but there are like more ways of providing it. We won't be like using many things in like, how to say it, in raw, like you will be seeing that it's using service discovery, but there are custom resource definitions and other things which will abstract that knowledge later on. Now, the thing we will be doing now in the next exercises is we will be deploying Prometheus inside a Kubernetes cluster. And oftentimes when I share that like detail, trainee students and folks ask like, yeah, but what happens when the Kubernetes cluster goes down? Yeah, the thing is probably you might be having some external monitoring or some additional monitoring which says, well, the Kubernetes cluster is down, you should be like doing something about it. If you, for example, add some like external monitoring and open up the Kubernetes API with root access, this isn't considered best practice. So like something check Kubernetes and then having access to everything could also like be backfire to like you shouldn't be opening up your Kubernetes cluster to external audiences, especially because monitoring requires typically root access, which means you might be exploiting sensitive data after all. So there are other advantages, like you can monitor the health of the Kubernetes itself. There are best practices regarding security policies and permissions, so that the monitoring system or that Prometheus doesn't need root access or something like that. Yeah, and like I said before, can use ping probes from external to monitor the monitor, for example. Now, thinking of how can we install Prometheus within Kubernetes? There are different ways doing so. One of the things I found really reasonable is using the Prometheus Operator project, which is like I wouldn't say extra. It's an additional project maintained by awesome people, providing the way to install Prometheus inside Kubernetes, and also automates the configuration of everything. So you won't be needed to edit like this configuration file and another one, because the idea is really to provide custom resource definitions, so you can deploy and manage everything from Prometheus to the alert manager to all the components which are then being deployed, and have like the best practices being available as well. The other thing which is helpful is like generating things which you would be doing manually or would need to copy paste 1,000 lines of configuration, which is done using the Prometheus operator already. And to be fair, I haven't looked into everything of the Prometheus operator. It just worked. And this was one of the reasons I said, okay, this is something I want to use and also teach in the future. Especially with kube-prometheus. This is like an opinionated deployment of the Prometheus operator and provides an environment which is called Prometheus-K8s, if you see it later on, which also comes with alerts predefined and specific rules, because like one of the things which we will be seeing later on is metrics are nice, but if there are no alerts, the dashboards might not be as useful as one intended them to be. So the idea is with kube-prometheus to install all the components, which you would install otherwise manually, which is like the Prometheus Operator. Prometheus in a high availability mode. Alert Manager is also in high availability, so like 2 instances. There is a node exporter. And the nice thing is there is like an adapter for the Kubernetes Metrics API, which is called kube-state-metrics, which doesn't need to pass anything else. And also like kube-state-metrics is a community project on its own, which is also awesome, providing all these abstractions and layers, which I don't even understand, but I can really like consume it. And the Prometheus Operator deploys it. Grafana comes by default as well. And the great thing is there are certain dashboards and also alerting mix-ins. They're called like mix-ins being provided by default. So when you install it, you get like out-of-the-box monitoring and can just work with it. The last point on the slide is dynamically create service discovery objects, which we will be seeing in a bit. We can just like define a target to monitor for Prometheus using a custom resource definition. And this is kind of the only thing we need to do, which is an awesome way of doing so. Now, the thing is, the kube-prometheus project has certain compatibilities being listed. So if you're not using one of the latest versions of Kubernetes, and I'm currently using 1.22, we should be using, or I should be using the release 0.10. Newer versions are then supported in newer Kubernetes versions. So the thing I did for this workshop to really like work is I've prepared a project which uses a submodule which has, or a Git submodule which only uses the 0.10 version, which is in this project. So in order to really like do that, we're gonna clone this repository now. And in order to initialize the submodules, use -- recursive. And we want to do it just right in there. Let's see. Oops, what did I do? Oh, probably. This is okay, for some reason the double dash is not correct on the slides. This is the problem. We're using different systems. If it breaks for you, please correct the double dashes. I will look into a fix later on. Now it tells us it has initialized the submodule and so on. So looking into what is like inside, it's a clone of the Git repository of kube-prometheus, and we can use kubectl kubectl create -f, but for now just the manifest. So there's like this order is required to create first the resources which are needed for the custom resource definition and also the monitoring namespace. And there is also like a check in there, which is this one, until the service monitors have been initialized, which should return no resources found. So this is kind of expected that it really works and doesn't throw an error. And afterwards, we can use cursor up to create everything else in the manifests. Eventually, it throws an error for the setup again, but this is also expected and should be doing something. So this is like the step watching things doing something, and we can have something to drink or something else. And afterwards, we should be having a little more pods, for example, which immediately see something is going on. We also notice an additional namespace, and we will be looking into this shortly. Now, these steps are just copied from the my taskbar is always switching when I'm moving my mouse. These steps are like found in the official installation as well. The only step, as said, is I'm using a different version for kube-prometheus now for this workshop, but you can like replicate this by yourself. Now, the thing we will be doing now in this workshop is we will be using port forwarding with kubectl to access the HTTP resources. So we will be accessing Prometheus, Grafana, and also the alert manager, and create port forwarding for that. For a production deployment, this isn't really what you want to do, but since I don't have any domain available and anything set up with an ingress controller in that regard, like Nginx or Traffic or something else, this is something which probably would make this workshop a little more complicated, and I wanted it to like keep it as simple as possible. So the next slide has some ideas how to get started, but we won't be doing it now. The thing we will be doing is like open a new terminal and adding port forwarding for Prometheus now. And probably I should have opened more terminals. Yeah, but in the end, we will be adding this into the background. So this is like the port forwarding command. We're mapping it to 10,000, and everything is def null, which is in the output, and putting it into the background. Sometimes it can happen that this is like it kills itself or goes like to def null itself, then you need to repeat the steps. But I've added all the instructions which are like needed in future exercises as well. So copy pasting the second one, and yeah, then we already saw something. End of file. Okay. Oh, this is interesting. Not working in the deployment yet. Then it probably makes sense to have it run in the back in foreground already. And the next thing we need to do, and this is like sometimes port forwarding works, sometimes it does not. Maybe my internet connection is not good because it's turning like 5 p.m. in Germany, and when folks are getting home, they are like starting Netflix streaming or something like that. No, could also be interesting. Dialing backend end of file. Maybe it's something else in the deployment. Let's see. This is what I was looking for. Is there something going wrong? Everything should be running already. Pending. The node explorer is pending right now. I would assume that everything works as is expected now, at least. When we will be checking first off the local host 10,000 port, which is now mapped to the Prometheus UI. And we should be seeing it actually, yes. And in order to test that, let me quickly see Prometheus HTTP requests. Yeah, we can, for example, and this is a nice thing with auto completion in one of the newer versions of Prometheus, we can use HTTP request total, can execute this query and visualize that as a graph. And we can see that something is going on already in the past 5 minutes. So we get to see that Prometheus is actively collecting metrics within the deployment. And this is kind of the HTTP requests which have been made already to the Prometheus API itself, which is currently me doing these requests. You should be seeing the same. You can totally query for something else, which comes up in the autocomplete version, but this is like really getting to know that it's up there, it works. You can also, and I did that in the screenshot, you can also switch to black mode if you prefer that, and do quite some more things, which we will be looking in a bit. But in the end, it's just Prometheus. You don't need anything else. Now, we will be getting certain Kubernetes metrics, and this can be quite overwhelming over time. So the idea is, and this is something we will be seeing in a bit, we will be looking at cluster metrics. So getting to know the node status, the resource usage, the deployments, the number of pods. This is everything which kube-prometheus and the Prometheus operator provides out of the box already. So we don't need to think about how does the PromQL query look like, how to like aggregate things, and think about how it's actually like being calculated over time, for example, or create all the dashboards and panels ourselves. This will be provided. The challenge for us is later on to figure out what is needed to figure out the health status of the Kubernetes cluster, or what should be put on the dashboard to immediately see a failure of certain things. But yeah, there are also like pod metrics for Kubernetes itself, for the containers, for the applications, but really like a lot. But it's great to have something, because if you don't, as said, if there is nothing, it's even harder to start with. For container metrics, the kubelets provide an embedded C-advisor exporter, which is also wrapped by kube-prometheus and can be used, for example, to do resource usage monitoring out of memory kills and so on. So like accessing container underscore CPU underscore system and so on can be very helpful to see things working in the cluster. The other thing, as a reminder, is kube-state-metrics, which provides an insight into the health of deployments, nodes, and pods. And it queries the Kubernetes API server. So it's like wrapping things to provide Prometheus metrics just out of the box, which is super helpful to get an insight and not like building it by yourself. In order to like have that visualized, the dashboards which come with the Prometheus operator are built in Grafana, and Grafana is an open source visualization and analytics software that allows you to query, visualize, alert on, and explore your metrics. I think I copied it from the website. So the idea of Grafana is to not only like use Prometheus as a data source, but also attach to MySQL, Elasticsearch, and other things to provide a way to create dashboards and using panels, being able to share that, and many other things. In our example, we will be using it as a dashboard to query the Prometheus metrics within Kubernetes. But on its own, there are like many more ways to do that. The thing which is great is like using the panels as a building block with the query builder. So like having auto completion and suggestions, which are helpful to not like I did 10 years ago, Googling for how this is called and how this is called, and then copy pasting and hoping it works. There are many like visual helpers available, making your life easier when you're building dashboards. So in order to access Grafana, we also will be using port forwarding, and this is the command again, in order to verify it works, and I'm hoping it works now, to accessing the Grafana UI. It will prompt us to change our username. I would recommend not doing that. So it's admin and admin for the purpose of this workshop. We are not exposing the ports anywhere, and this is like 1,000 pop-ups that I should be changing my password now because I just want to like really use that for this workshop. I think there are ways to kind of for the Prometheus Operator and the kube-prometheus deployment. There are ways to disable the Grafana password reminder thing, or to customize it in a way to, for example, attach to your SSO and RBAC integration and other things. So this is configurable, but for this workshop, I just said, okay, let's dance the browser dance and have it available for now. So this is like the Grafana interface, and we can also see that there are recently viewed dashboards which have been pre-installed with kube-prometheus already, which we will be looking into a bit, or at least right now. So the next exercise after like logging into Grafana is to figure out what we have there. And as a reminder for myself, I've put in there that we will be looking at the Kubernetes API server, at compute resources, at the kubelet, and we can also see the health status of Prometheus itself in the deployment. Okay, so from the menu over here, we can use browse and default. Okay, we're going to actually navigate into this folder right now. And the Kubernetes API server, for example, could be interesting. We don't have any activity that passed 30 days yet. Okay, this is kind of expected. But we can see that we have write availability. Okay, we have something going on already. The CPU usage is currently at, okay, it's not so much. But we can like deploy something, then the CPU usage will be much higher. Or deploy something over the Kubernetes API server. We want to deploy something, for example, which queries the Kubernetes API server quite often, which we might be looking at the end with chaos engineering and so on. But yeah, in the end, it's providing us with some resources, and I think we can navigate back like this. And it's again, I don't know everything, so I also need to write it down and use the slides as a resource. We have the compute resources for the cluster. And since we don't have everything available yet, this is like the cluster is using a little bit of CPU. And the good thing is, for example, if you're adding monitoring or like the Prometheus operator into your monitoring, there is a certain cost of resources and infrastructure, like which is assigned to the monitoring namespace. So if the monitoring namespace, for example, consumes all the resources in your Kubernetes cluster, you need to think of like scaling the monitoring and the deployments in there as well. But yeah, kube-system is consuming something and so on. Now this is, we get to see that we have the ability to get dashboards like grouped by namespaces, for example. This is using PromQL in the backend or in the background, and it's super helpful, like to being able to see which namespace consumes how much memory or affects other things as well. The other thing we can inspect is the kubelet, and there are potentially like, I didn't modify anything, but yes. The kubelet itself, there is like the container status, pod start rate. So like if pods are restarting a lot, this might also be something you want to alert on. Or at a certain point, like crash loopback off. When pods restart too often, then Kubernetes kind of injects a delay, which is like the back off term in the description, in order to like not to stress the restarts. But in the end, you should investigate on these errors, why they happen. And this is like a really helpful insight. Now, okay, we have the Prometheus overview as a last one to look inside, and then we get to action ourselves. There is the Prometheus overview. So we also get to see that Prometheus itself is healthy. It has a lot of targets it wants to scrape in this deployment. And I think the query rate, yeah, this is us in that regard. Yeah, so in the end, we get a lot of things already. And yeah, I think this is something I copied from a longer running system where we can see the availability and so on. But now we want to create our own dashboard or dashboard group. For now, we navigate into dashboards, create a new folder, call it workshop, and then we create a new dashboard. Okay. I'm not monitoring the questions in the chat, but if there are some like, or if you want to like, if you have your dashboards available or want to share tips and tricks, potentially you can just go ahead over there as well. What we will be doing now, let's navigate into the dashboards. And for some reason, this looks like an error or a bug. Or maybe it's a feature, I don't know. No, just kidding. We want to create rows. Over here, we want to create a new folder, which we call workshop. We also call it Kube Simplify workshop. Simplify workshop. And we want to create a dashboard. Okay, now it greets me with something, but this is like the second part of the exercise. When we have a dashboard, because the dashboard is not saved yet, but it asks us to create a new panel before saving. We want to add a new panel, and we want to monitor specifically the container processes. So we get to see something. So in order to add a new panel, we will click on this section over here and get greeted by a lot of data, which I would recommend like focusing on. Okay, this is like the preview of the panel. This is the query. So this is like collecting the data source and then executing PromQL for our example. And on the right-hand side, we can modify the panel title, the legend, and many, many more things before we can like save and apply this. Now, this is demo data provided by Grafana, but we want to select Prometheus, and the metrics browser should be container processes. I can just use enter and either enter or just moving the mouse focus out there to apply this. Now, we can also like modify and say we want to see the last 15 minutes, maybe 30 minutes, something like that. We could also like modify the bullets or make it a table instead of a graph or something like that. But this isn't something we really want to do now. We just call it container processes, and don't be irritated. My browser knows that I've been giving this workshop in the past, so this is like stored in there. This is not a Grafana autocomplete feature. But yeah, this is something we want to apply now. So we have our container processes over here, and it should be working as expected. I think the screenshots should still be applicable. I was moving a little too fast in the exercise. We are now like editing the panel, like container processes, applying it, and we're saving it as a first dashboard now. So the important part is this is still like a draft dashboard, and now we need to save the dashboard. This is this button, and we want to call it first dashboard. In the kubesimplify folder, and this should be good to go. Now the dashboard is saved, and we could, for example, share it, I think. Probably not. Oh, there are some dashboard settings. Yeah. The thing is, you can export a dashboard as a JSON file and then import it in a different installation, or even like upload it to the marketplace, or store it in your preferred Git repository, and so on. But for us, for now, it's really like getting to see something. Can also set the refresh interval, so the browser refresh, and it should be updating automatically over time. The most insightful thing right now is can like hover over this. We can use drag and drop to resize everything. This works like a Git history, so you can actually add notes when you're modifying a dashboard and so on. But this goes a little bit into deep for Grafana in that regard. So now that we have created our first dashboard, we want to create a Kubernetes dashboard for the following metrics. And in order to practice that, we click on the kube simplified dashboard thing, or we're just navigating back into dashboards browse. I think this is better to highlight. And when we hover with the mouse over the kubesimplify workshop, there is go to folder. So we are going into the folder, and we are creating a Kubernetes dashboard, or Kubernetes Observability dashboard, a monitoring dashboard, which which we, sorry about that pop-up, which we will be saving as Kubernetes yeah, we will be saving this as an empty dashboard. Okay. Now, one of the things we want to inspect is like the container metrics. So previously I mentioned that the kubelets provide the cAdvisor metrics, which we will be using. And it's at some point it's interesting, like what are the resources being consumed by containers, like CPU usage, which can be divided into system, user, and overall usage, and for example also the container memory. So for example, if an application is leaking memory over time, you might be seeing a trend that memory is going up, which can be an indicator whether you should be doing something, or like restarting the pod to remove the leaks could also be an option. But in the end, if there is a memory leak, it should be fixed in the application and not in the deployment. Now, the thing we want to do is first inspect the compute resources for the cluster to see what is going on, and then build it ourselves. Now, moving back into Grafana, into dashboards, we do have the me and navigation pros. We have Kubernetes and compute resources cluster, this one. And this provides us an overview already with CPU utilization requests and so on. So for example, the thing we can do, you can edit a panel, and this goes a little beyond the workshop now, to edit this panel, and there you get to see the PromQL query. So you could, for example, copy paste that into your own dashboard. This is like one way of figuring out how these things work. But for our example, we won't be doing that. We will be just looking into querying the container metrics ourselves. So we're going back into our own dashboards, and in the Kubernetes dashboard, we will be adding a new panel. So let's move into the Kubernetes dashboard, go to this folder. We have our dashboard over here, and we want to add a panel which should be using the Prometheus data source. And then we want to look into the container CPU usage in seconds for a rate of 1 minute. Okay, let's try to build that. We want to have the CPU usage in seconds total and in square brackets 1 minute. This doesn't work. Yeah, because I didn't specify any range. Well, I need to specify the rate. I was kind of expecting that Grafana would tell me now. Apparently, I need to know that by myself. Okay. This is the first thing we want to be adding, and we want to have like 30 minutes to see a little more than that. Or maybe in the future. Let's just keep it 1 hour. You can also leave the 6-hour default if you want to. The other thing to add is the summary by namespaces. So this is like the same rate, but providing sum as a function, and then group by namespace. So let's try to replicate that with the existing query we have been creating over here. So we can copy that, and we want to add an additional query, which is the sum by namespace and this query. Does it work? No. Oh, yeah, I made a mistake. Actually, when you're creating a sum, you need to provide this in brackets. And so we get to see the summary of all namespaces. So this is like each namespace on its own, and this is sum by namespace. And plus query sum by namespaces. We are saving the panel as a CPU container CPU usage rate. Okay. This is currently in seconds. Let's pick that one and apply this. And we also want to create a second panel, which, oh, this is about the memory. We can, oh, we didn't deploy that yet. We can just use container memory usage bytes. We will be deploying a service demo in a bit. I think I mixed up the exercises. We want to look into container memory bytes. Usage bytes. Okay. To be honest, use usage bytes. Many time series results returned. Okay. Consider aggregating with some. Oh. Yeah, we can totally do that in a bit. By pod and container. Okay. We can, let me see. We have the ability to, we can like select the metric, then we can apply labels using this one, and we can do that by container, which could be potentially, we can do that in a bit. Yeah, but let's just oh. Options now. Where is the panel title? Oh, there is the panel title. Container usage. Just add it for now. And save the dashboard and look into this in a bit when we have applied an application. But this is like also to practice. Potentially, I need to take a note. Yeah, and in the end, this doesn't make sense right now. We need to do it later on. For kube-state-metrics, there's also a way to query that ourselves, just to see which PromQL queries are available. We can add a new panel in the Kubernetes dashboard, give it a title for the replica status, and query the kube deployment spec replicas and status replicas available for the specific job tag as a selector. Now, let's add a panel in the Kubernetes dashboard, use Prometheus as a data source, and kube-state-metrics, no, kube deployment spec replicas. And spec replicas. And we want to tag it by kube-state-metrics. This is like using the angel brackets. And the second query we want to add is the status available. Okay, kube deployment status because available, and same again for the job Completion is nice, so I don't need to like think a lot. Yeah, this is the replica state. And try this one as well. So we get to see the different containers and their replica state. Currently, we don't have anything deployed yet in our Kubernetes cluster. So we're inspecting kind of live metrics from the monitoring and the kube system namespace. The other thing to keep in mind or to like remember is that Prometheus wants to monitor everything which has a /metrics endpoint. So we can use Prometheus exporters like inside the Kubernetes cluster, the node exporter, or for example, using a blackbox exporter, which is like a ping probe to monitor, or instrumented applications. So applications that already provide an HTTP endpoint using the /metrics endpoint and also the OpenMetrics format for exposing the values. And the great thing is around this that the Prometheus operator provides a ServiceMonitor custom resource definition for this. So you can define the target endpoints and it auto discovers the targets from different namespaces. So you don't need to worry about like, how does this work together and this work together? It's just really like using a custom resource definition. So whenever you deploy an application that provides a /metrics endpoint, ship the ServiceMonitor CRD with it, and you're good to go to integrate it into your Prometheus monitoring deployment in Kubernetes. Now, the thing we want to do now is to practice this one. We want to deploy a demo service application. And before we do that, and the thing is, you shouldn't trust anyone on the internet deploying your YAML file and say, hey, please apply it into my Kubernetes cluster. We will be looking what we will be doing here. So in the end, oops, did I rename something? Potentially I renamed something. We have the Prometheus demo service over here. And oh, I moved it into a subdirectory. Okay, so we need to like fix this now live. This is a demo service which uses a container that exposes /metrics for some demos. So the container is actually provided or written by Julius Woltz, one of the co-founders of Prometheus, and I forked the project and just enriched it with some builds. It listens on port 80, and this is like the deployment parts. We're defining 3 replicas for that, and the service itself exposes port 80. This is the thing which is about to happen now, and we are going to apply this. And before I do that, I will be fixing the slides live because this is how we want to do that. And in order to access this one, we are going to open this raw, copy paste this one, and also fix the slides. I've never done this in a workshop before, but it's nice that it works. So we get to copy this and apply that into our now the terminal is a little cut. We're applying this service into our deployment. It will be using the default namespace just for simplicity, just to like use it as is, as a demo service. So we get to see that we now have 2 ports, 3 pods being created because three replicas, and this is now running in our Kubernetes cluster. So the application itself provides some metrics, and this is like to verify that, but we really want to monitor that. So when we open the Prometheus monitoring targets, we can see, or we don't see like something like ECC yet. So there isn't something which is monitored already. There are many other targets which are being auto discovered, but our deployment isn't monitored yet. In order to like fix that, we need to create a ServiceMonitor custom resource definition that tells Prometheus, hey, please monitor this. And the thing we do again over here is we want to monitor this one. So the idea is provide the ServiceMonitor CRD, apply the label, and it matches, the selectors match labels for the app ECC demo service, which our deployment and service provides, and the endpoint is the port mapping web, which is defined on the other side. Now again, in order to use that, open raw and deploy this one into our Kubernetes cluster. And we now have the ServiceMonitor CRD created. So the thing which should happen now is when we open up again the Prometheus targets, so like it's /targets on the Prometheus UI, at some point we should be seeing the ServiceMonitor CRD, if I didn't do anything wrong. For now, we can also use get service monitors, and in the monitoring namespace, this is what we have in there. And if we want to have it like in all namespaces, we have the ECC demo service in the default namespace. So at some point, Prometheus will pick that up. It takes a while because the scraping of the service discovery targets is not like live. It I don't know exactly, is it 10 seconds, 30 seconds, something like that. So need to find the right browser window, and probably I should close certain things. Now, we have the ServiceMonitor targets for the ECC demo service for all three replicas. So the only thing we did was like a short configuration for the custom resource definition, and now we can actually like monitor these services. Now, if I click these URLs, these are internal IP addresses in the cluster. I cannot access them. I could if I would be using port forwarding. But the more interesting thing is, since Prometheus is scraping these targets, there are metrics available already, and I can see, hey, I have labels applied automatically. So I have the container name, I have the endpoint, I have the instance, I have the job, the namespace, the port, the service. So this is provided out of the box using the ServiceMonitor CRD. And I can actually use that data to query for these metrics in Grafana now, which is a beautiful shortcut to, I have no idea how to do it manually, to be honest. So let's try that and add a new panel in Grafana. Use the data source Prometheus, and in the metrics browser, we are looking for demo underscore CPU. And we also want to filter by the container, which is called ECC. It's an abbreviation for everyone can contribute, -demo-service. hopefully I'm not talking too fast, but I'm looking at the clock. We are like 1.5 hours in, and we have quite a few things to learn. So I'm moving forward with the practical things now. So now I will be closing certain things. This is something we don't need. We want to navigate back into our Kubernetes dashboard, which again we can access from over here, navigating into the kubesimplify workshop and then opening the Kubernetes dashboard, which we will be just adding a new panel over here. Then go again, add new panel, typical workflow. So we're learning as we go along. New data source. And we will discuss later on how to automate the creation of dashboards, because doing that manually all the time is like, think of manual work as a bug. A friend said that a while ago. We need to automate certain things. But for now, we are practicing our PromQL knowledge and also how to use Grafana in that regard. And we want to search for demo CPU usage seconds in total, I think. Yeah. And the label should be, and let's click on the metrics browser. We want to use the label container, which is pre-selected, which is awesome. And from there, we can say we want to just use, we have a lot of containers here. We want to use the ECC demo. This automatically creates like the selection. So yeah, the resulting selector is container. Should we be using this raw? Should we be using a RAID? Oh, no, actually, this is like the hint that we should be use as a RAID query. Okay, we will be using it as a RAID query as suggested. For some reason, it doesn't like us with the interval, but we can like manually replace that to 5 minutes, for example. And I did something wrong. No, this doesn't make sense. Again. Yeah, probably. Okay. Now I'm learning something new today. If I type it in the metrics browser above and open it later on, it doesn't copy it to select the metric. Okay. Okay, we want to. This is what I expected. This is like the preview of the selector. So like we are accessing this metric, applying the container label, and we can use it as a RAID query. This is what I want. This is okay. I don't really understand where this is coming from, but this is probably a default which is not set. For our case, we really want to like focus on this one, and we can see that the demo service, and this is also the reason why we created 3 replica sets, just to have some data available to play with. We can see that there is a lot of things like going on, some demo stuff, and can save that panel as ECC demo service and get to see that over here. Am I doing my own exercises right? No, it says 1 minute. Okay, you can modify that. It's like 1 minute sampling or 5 minute rate sampling with that regard. So typically, when you're coming from the Linux or Unix world, it's like CPU usage is like calculating it over time, because the raw value of CPU usage doesn't give you any insight. But if the rate exceeds from 1 minute to the next minute, this can be an indicator whether CPU load is going wrong or not. Okay, we have applied everything, and I was a little too fast with the exercise. But yeah, now we can see certain things from the CPU usage. And just to recap, This is a demo application which has been deployed. We deployed it in a little bit over here. And in order to verify what is actually going on in the demo, we know that this is like this project which provides this. So in order to access this, for example, can see that this has been forked from Euler's repository. And oh yeah, I needed to change the Docker image to Debian because it didn't work in my tests. But in the end, this is an open source project which you can inspect for your own deployments, for your own learnings, which really allows you to immediately see something in the deployments and also provides a great insight into how to instrument your Go code in this regard, with this regard to add some metrics and see something. Now, when we move on, and I call this like monitoring 2.0, but probably it's like just monitoring and things you want to apply and want to learn. Like we know that like we have service level objectives, we have monitoring metrics, we have the key or the key to indicate things, we have tags, and we have the values. Now, one of the things you can do, and this is more of an advanced exercise because not everyone knows Python. I know Python, but I also have zero or little knowledge in Node.js or other applications. So it's really like getting to dive into or learning how to instrument application code and use the Prometheus client libraries to instrument your code. So when we, for example, look into, this is the Prometheus client library, but we can just, and this is one of the set examples for Googling together, client library. We do have the documentation for Prometheus, the client libraries that are officially supported, and those which are provided by the wider community. And you can see there is Go, Java, Python, Ruby, Rust, and as well as like can instrument Bash, C++, C, and many more, and also like Node.js, which I probably would need to learn. For Python, this is the official library, which also provides a quick 5-minute success demo, which you can use, and also like wrap around the service deployment or the deployment and the service, and also the service monitor. This is something I did for this exercise. In the end, it's really up to which language you want to learn or use in your applications later on. For me, this was now Python, and the Python deployment. I'm talking too much, losing my voice again. This thing has the deployments, which is kind of a copy of the other thing. And the important thing is like how does this look like? We do have a deployment which provides us, we can query something, we are creating a request, which in that regard is just some random sleep time, and this is being monitored by that. You can see that I created this for a workshop and the previous workshop. So one of the ideas was to really do that together now, but since we are not in a room, but it's potentially a little complicated to follow along. In the end, the idea is to really like being able to fork the project, modify it by yourself, add some code, duplicate the things which are implemented here, and deploy it and see what is going on. Now, I will do that on my own pace now in a quick minute, probably not because I'm not logged in. But in the end, this is the Python deployment, the application. we can deploy it. So we can, this is, yeah, we deploy the application itself. And the async exercise for you is to fork the repository, to modify the code as instructed in the slides, and modify the deployment or the image location in the manifest, and have the first success with the deployment. Not sure why I'm logged out currently, or logged out in my GitLab.com account, but yeah, probably because I'm sharing the screen. Okay, this is basically what we did before with deploying, creating a deployment, a service, and a ServiceMonitor CRD for the Prometheus Operator. And we should be seeing this deployment in the targets. So if we're moving back into Prometheus, into the targets directory, we should be seeing something, hopefully soon. It's the Python. Python is not there yet. Yeah, it's the ECC Python service. If I would have more time, I would probably create something in Rust, but this is not like getting to know things, setting up a development environment. If it's not there already, and really like getting started will take like up to an hour or something. So there is a note at the very end of the workshop, like learning instrumentation or code instrumentation for observability. This is like a workshop on its own, which probably we can do in the future, or someone else does it, like maybe Dotan Horowitz from Logs.io wants to do it for OpenTelemetry, for example, or someone else. Just making suggestions now to Saiyam. But there is a lot of things to learn, really. And I'm not trying to replicate everything in this workshop. Now, I was just trying to figure out why this is not there yet. Oh, yeah, we actually have met a good state. So for the first deployment, this happened already, but the second isn't scraped yet. But this will probably change in a bit. Now it's scraped. And we also have the metrics, and we see that there are like different labels applied or relabeled for that deployment. And we also have the possibility now to monitor it again, which we can request processing seconds count. Okay, let's try that. Quickly in the dashboard, create a new panel. And again, Prometheus. And the metrics browser this time should be, good question. What did I say? Request processing. Okay. I'm a little confused by this many tabs. Request processing count. This one. The container should be this one. So we can actually like use this and actually use it as a read query again. And we do have only 2 replicas. Yeah, so we only have two data points. Not sure. Okay, this one goes down, this one goes up. It uses random values, so in the end, it's the Python service, which is exposed as a metric. And for example, if we would be adding more metrics or like scaling this up to a third replica, we would be seeing this immediately here. So there's no action needed for like modifying when you scale things up. It's only what matters is the query, the PromQL query, and the label selectors and so on. Yep. We won't be doing the code modification. As said, this is like left as an exercise to the reader and for later on. Now, we have talked a lot about like metrics, and metrics are really like great, and we have looked at dashboards, and oftentimes you have if you have an office, if you're not all remote like GitLab, no, if you want to have a dashboard like a monitor at the top or somewhere else, like working as an SRE, you probably have that somewhere, and oftentimes you're monitoring or you're seeing a lot of metrics. But on the other side, it's like it can be business critical to get alerted from certain thresholds, and this is something we call alerting, and also incident management attached to certain alerts, and also like service level objectives. And we will be dealing with that in a bit. The idea is like what is coming after metrics. So like the definition of failure, the definition of not healthy. We want to do something because something failed, like a threshold has been violated, and then trigger a rule being matched, like notify and raise alerts, notify a specific or defined set of teams, of personas, and so on, like the who. And the how is like documentation for incidents. So if there is an alert, it shouldn't be just a message, hey, something is broken. It's helpful to provide as much context as needed to really fix the problem in a stressful situation, which can be like weekend, 3 a.m. in the morning, and the customer is calling and nothing is working. Like having a run book to replicate things, to fix things, and also being able to document the incident in a ticket system, in an incident management system, and also define corrective actions, for example. And the idea is to really reduce the mean time to response, which is called MTTR. Some call it the mean time to resolval or to solving problems. Could also be the case, but it really needs like iteration on that. Now, when we look at alerts with Prometheus, and this is kind of the same with Prometheus running in Kubernetes, Prometheus evaluates alert rules and sends these alerts to the alert manager. The alert manager can be used for grouping so that like you don't have any duplicated alerts. It provides with inhibition, which is like you can suppress alerts when others are fired already. So your mobile doesn't get DDoSed from notifications and alerts. And it's also possible to acknowledge a problem, which is called a silence. So you can mute alerts for a given time and say, hey, I'm working on the problem. If it's not fixed by like 5 a.m. in the morning, then please alert me again about this. This is essentially helpful for on-call shift handovers and other things, like saying, okay, we're expecting this to being fixed from a rollback or for something else. And if it continues to be a problem, please continue alerting. For the transports, you can use various integrations like the default, not the default, but SMTP, which is for email. You can configure webhooks, push over, and SNS, which I think is an AWS service. I don't really know about this, but it's also possible to integrate pages and also use chat, so Slack, WeChat, Telegram, whatever comes to mind. With regards to Kubernetes, the Prometheus Operator and kube-prometheus deployment already provide certain alerts out of the box, but it's helpful to know what else is out there or what could be interesting. So it could be like an infrastructure alert, it could be something around memory, CPU, or even disk pressure, the pods, the error rates, and the response times from services and from APIs, for example, and the overall reachability. I found a website which is called awesome-prometheus-alerts.grab.to. And there are like rules available also for Kubernetes, which allow you to like copy paste them and also inspect them, whether they are being useful for your production environment. Now, if we want to integrate the rules or the alert rules into the Prometheus operator, because typically we don't want to like keep a separated set of resource definitions and alert rules ourselves. There is the way of providing or using the Prometheus rule custom resource definition, which wraps the Prometheus configuration language into the Kubernetes native custom resource definition language, and allows you to really like have that applicable as a Kubernetes manifest, and just benefit from Kubernetes native alerts with Prometheus. This takes a bit to really like learn. I've like highlighted certain things which are familiar from the previous rules, but in the end, an alert is like defined in a group. There are rules which need to be like evaluated. So the alert for this one could be kube-state-metrics list errors, and the annotations, which is a description and a summary of what is going on, which also provides, for example, a runbook URL so that you can immediately take action on the error. This is important context to provide. The expression is written in PromQL. So this is like a multi-line PromQL expression, which uses a comparison operator, whether the rule alerts to Boolean true or false to being executed and the alert being fired. And it needs to be active for 15 minutes, for example. So for testing, you can like reduce it to 1 minute, but it's really like defining the state of error. If it happens for 15 minutes or longer, it should be alerted and not before. And you can also apply certain labels to that. So in the end, it's like it's a super useful language to being used also with the Prometheus operator. Before defining all alerts by default and have like 10,000 things which can potentially be alerted, it also makes sense to really like see about what you need and what you immediately would be seeing. So like in a chat, you would be seeing something immediately, but for longer term installments in production, it makes sense to discuss and also document refinements. So maybe having some grouping, always like doing a review of what you're getting within incident management systems, because the problem of getting tired of too many alerts, which is called alert fatigue or fatigue, this is real, and it can burn out everyone. Or someone like I'm doing that as well. I have a dedicated folder in my mail, in my inbox, and there are alerts in there. And if I have like 10,000 unread alerts, you can probably imagine the problem. I'm not reading any alerts anymore. So it's like really important putting out the focus on what is important to fix, and not just have 100 notifications. Something is broken, and maybe this could be the root cause. And it's like really important to review that on I wouldn't say on a monthly basis, but maybe quarterly or half a year basis to really figure out what is the best strategy for alerting. Now, how do we trigger alerts? Well, there are certain strategies for that. One of them is kill something in the cluster and see what's going on. So like killing a pod, actually like removing a deployment. This is something we will be doing in a bit, and see how everything like works out. So in the end, it's really about like finding a use case to trigger an alert, and how to simulate a production incident and break something, to see whether the alerts are being fired, or wait for the next production incident and potentially define yourself or like a test account as alert receiver, and not the entire team which doesn't know what to do with it. Depends how things are going. Now, the alert manager itself is using a different HTTP port, which can be accessed with our port forwarding on port 30,000, hopefully. Yeah. And in there, we are seeing some alerts. And to be honest, there is a pod not ready yet. So the node exporter doesn't start for some reason. And watchdog sent something before, but in the end, this is like the interface, and you can use certain grouping to filter things, do silences, and so on. So this is the primary interface for the alert manager. And the thing we want to do now in the next minutes is we want to deploy a demo application. We want to monitor it. We want to define an alert for it. And then we delete the deployment because for some reason we decided we want to break it. And the expectation is that the black box ping probe, which we'll be using, will alert us based on that. And in the end, we should be seeing an alert being generated in the Prometheus Alert Manager. Now, this requires a couple of steps. And yeah, after 2 hours, I totally understand that that it might be a little too much right now. So I'm trying to keep it as slow and as insightful as possible because there are many switches between the slides and the terminal now. The first thing we want to do is we will be looking into an application called podtato-head. And the potato is not by accident a typo, this is intended. So this is like a demo application which provides us, and again, let's go it. Podtato-head. This is a demo application which helps testing continuous delivery scenarios, Kubernetes deployments, and so on. So this is like one of the cloud native demo applications everyone keeps using. And it has like a funny pirate head thing. So you can like break the leg and see that it's still working and so on. What we will be doing now is I've prepared a deployment for podtato-head, which is ready for Kubernetes. And before we deploy that, I think I opened it over here. Yeah, the thing is, it will create its own namespace for potato kubectl, then the head, then the legs, and so on. So this is the only thing I modified is, I think, the load balancer or the node port in this example. I think it was the cluster IP actually. And again, since I moved my mouse over here, I don't want this. So I'm having a dual. I'm having an external monitor and macOS doesn't figure this out. Anyways, we want to deploy this one. So it doesn't do any harmful things. It's just a demo deployment. And we want to deploy this and wait until it's being deployed, hopefully fast enough. And after it got deployed, we can see the ports in the potato. I think this was. Yeah. So this has some ports being deployed, the head, the entry, left, right, arms, and legs. And we can add port forwarding to that as well, which allows us to access the web interface. So again, let's do it in here. It doesn't like that for some reason. Okay, let's do it in another terminal. Background daemon. For some reason, the deployment took a little time. Okay, port forwarding isn't the best way to do things, but again, for demos or for workshops, it's better or works more reliable for me as well. Okay, so this is podtato-head running and everything works. Now we want to configure an alert for it, or we want to figure out when it's breaking. And one of the things is I want to be using not the default, like I'm killing a pod, I'm removing a deployment, and then like creating alert when the deployment is gone. I was thinking of like, this is a web service and I can ping that. And with Prometheus, I'm able to deploy a blackbox exporter probe, which is also provided by the kube-prometheus deployment. And this one pings the potato-head web service. So like the port we just exposed through HTTP, this gets pinged. And when it's not available, so like probe success in this query down below, this is not successful anymore. We are alerting later on. But in the end, we really want to see the probe availability and the probe duration. So like, what is the response time to the website? This is something you can also like use for monitoring external services or monitoring the response time to a specific website internally. Now, what we want to do or need to do is, this one is the probe we want to deploy, just to open it up again. And the main like difference is this is of the kind probe. It has certain default labels applied. It uses the namespace monitoring, and the specification follows the configuration of a black box exporter probe. So this is like Prometheus specific. Interval is 60 seconds. The module is using HTTP, and it's expecting like 2xx means it expects a 200 response. The prober is the black box exporter, which has been, or which is already running in the monitoring namespace at this port. And yeah, it's we want to monitor the potato head. So this is like the configuration required by the black box exporter. This has been prepared, and we want to deploy this into the Kubernetes cluster as well. And going back here again, no, kubectl create-f and the URL again. And the probe has been created. So it's kubectl get probes dash monitoring, I think. Yeah. So now we have created a black box exporter probe, which pings the Prometheus, the potato head deployment. And in order to monitor that, because this gets automatically added to Prometheus as well, the metrics, we can add some Grafana panels. So, and now I'm cheating because this is a query you can't really type. You can copy paste it from the documentation. We are navigating back into Kubernetes. Into Grafana in the Kubernetes dashboard, we're adding a new panel, and we're selecting Prometheus. We are copy pasting the probe success for the environment, which is like in this range, and this is the we are multiplying it by 100 because it's the percentage. So this is the probe availability in percent. And check whether, yeah, we want to add two different panels. So we don't have any data yet, but this is potentially going to change, hopefully. But for some reason, why isn't there any data yet? Environment, virtual time. The other thing which is helpful, moving into not the alert manager, moving into Prometheus, for example, and see if there is something returned directly from Prometheus or not. Okay, yeah, it's 100% currently. So Prometheus already knows about the data, but for some reason, Grafana didn't pick it up yet, which just shows a way how I debug things or troubleshoot things. I'm trying to remove as many dependencies as possible. And since I know that the data needs to be in Prometheus, I'm looking at the Prometheus itself and not at using Grafana as an external way to verify that. Okay, it's great when things don't work, so I can show some things how I troubleshoot this, and now we have it here as well. The other thing which we can monitor is the probe duration using the same query, but for milliseconds, which means multiply by 1,000, just to have something available. And yeah, this is like, again, query handle creation exercise, copy paste this one and call it probe type duration in milliseconds. Typically you would like look into the legend and other things. I'm just keeping it as simple as possible to being added. So now we see the probe duration like is 300 milliseconds, and potentially it will go up and down a little bit in the next time, depending on what we see. We can also enable like refresh again to immediately see something. Now we know that our deployment is up and the availability of the probe is still 100%. And this might be flapping between some milliseconds, and everything looks good. Now, in order to like, I think, I kind of copied that. This is like a duplication of the exercise. Sorry about this. I think I should have removed that. But maybe Google Slides didn't save that. But yeah, in the end, we should be seeing something like this, like over here. Ignore this part. Now, the other thing is we want to get alerts based on when something is wrong with the query for the black box probe. So, and I've copied this over here. The alert rule, which we will be creating as Prometheus rule in a bit. This will be a critical rule. The kind or the alert name is probe failing, and the expression is to check whether the probe is up. So this is like, why is this an 8? Shouldn't be an 8. Let me check this one. Let's open this one up. Okay, it just reads as an 8. It's a 0. When up is 0, which means it's down actually, or the probe success is 0, it's also a similar failure condition. And just to see it in the workshop, it should be for 1 minute so that the alert is triggering, and we're using a simple description. So like potato-head probe is down and so on. Now again, I want to deploy this. You can just use the URL and go back to the terminal and say kubectl create -f and the URL. And we have a new Prometheus rule created. So Prometheus rules, sure which namespace this will be using. Yeah, okay, yeah. We have it in the monitoring namespace, potato-head probe alerts as a rule. And now we're good to go. So we don't see any alerts yet for this specific type, but we should be seeing something soon. But first we need to break something. And this sounds like us breaking things is fun. Yeah, sometimes it's fun to really like test the system and see how it behaves when you break something. We'll come to more like automated breaking things in a bit. The easiest way to break the deployment now with the probe is to delete the deployment. So in order to delete the deployment, it's basically reversing the creation or the apply. And you could also like kill something, but it's like really like deleting the potato-head deployment. So everything is gone and the black box probe points to something which has been deleted. So in the end, there is somewhere we had this, and this is now gone. And we are expecting to see alerts, hopefully soon. Probably this is the best time to take a short break. Maybe. Let's see. It's probably the 1 minute demo effect. Maybe we get to see it over here as well. No, the probe is still up. I think there is a certain like delay. The probe runs every 30 every 60 seconds. There we go. And the scraping and also like the alerting. So like we see it over here, but we should also be seeing it inside the alert manager. Oh, now the alert manager triggers after 1 minute. So we need another point of measuring to really trigger that. Maybe I should change the exercise to be to being more responsive. We should be saving this dashboard once again. Sometimes I'm really like used to everything autosaves, and when something doesn't autosave, everything is gone. Similar to git stash and hiding things while you're changing branches and then wondering why it's gone, but actually it isn't gone. But I've seen myself writing code in duplications because of that. Different story for a different workshop. We now should be seeing this going down to 0. And I'm currently wondering when we will be seeing alerts. We have a new alert, which is called probe failing, which is awesome. And we get to see the information. Potato-head probe is down. Yeah, we didn't provide any like more things to be looking at. And potentially we also like need to, if you have like an ingress controller, you should be able to like modify and configure that in a way it's accessible to you right now. This currently doesn't work because there is like no port forwarding. But in the end, the alert has been triggered, and it proves like the alerting rule which we deployed earlier works, and we are getting now continuously alerts for the broken deployment. So this is like one of the simplest examples I've found for alerting, except for like removing some ports and triggering something. Yeah, so the thing is, this was like a simple alert. If you think of alerts and notifications and problems in your production environment, this is something which is called, or which is found under the umbrella or under the term service level agreement, objective, and indicator. And to dive a little bit more into this in the next minutes, because I think it's really important to learn and understand next to everything else which we talked about in the last 2 hours. An agreement means that you have an agreement with your customer or your user base. You're providing 99 99.5% of availability of your services. The objective for your teams and for yourself should be higher, like 99.9%, because 100% is like a myth in between, like for SREs and DevOps engineers. And the indicator which provides the insight could be errors, latencies, and whatnot. And in order to really specify that and make this like accessible, you're using kind of like error budgets. So within the error budget, everything is allowed to fail, but what triggers a violation of the service level objectives, which is potentially fine, but if you have an agreement with your customers and you go to 99.1% availability over the year, for example, you might be paying a penalty, or the customer doesn't need to pay that much, or something else. So it really depends on the contract in the background with the customers, on what penalty or what measurement has an impact. But this can get tricky, and this can also like harm your business in the end. The idea is how to like get confidence like with service level objectives, and how would you apply service level objectives. We know about metrics. We have seen that we can create alerts based on the PromQL queries, which is kind of what we define as a service level objective. So we are expecting, for example, the probe, which we have been using earlier, to be available 99.5% of the time. The service level objective is much higher than that. And in order to get started with service level objectives and also getting to know what is going on in your Kubernetes cluster, there is the way of defining the 4 golden signals of monitoring, which are also defined in the Google SRE book, which I would totally recommend getting, and also getting to know how things can be identified, especially when you're looking at certain web services or services being discovered. Latency, traffic, errors, and saturation are one of like the key factors of an incident. And when you see that the REST API of your services runs into a saturation problem, or the error rate increases, this is a good indication that something is really broken in your environment. It doesn't really matter the state, what exactly, but it's an overall signal to really get an idea, hey, we need to be looking at a problem and maybe declare it an incident, or maybe there's a hotfix available, and so on. The other thing I want to bring to your attention around service level objectives themselves is you don't need to be learning or copy pasting the Prometheus rules and everything else around it all the time. There are also like initiatives like OpenSLO as a specification, generators and management with Sloth and Pura, I think I pronounced it correctly, which allows you to specify the service level objective for a given service and then generate the specification and rule set automatically, so that you can just like integrate them with existing Kubernetes deployments and Prometheus, for example. This is worthwhile to dive into asynchronously. For having ops dashboards and iterating on everything, like there are many dashboards, and we didn't really touch on everything in this short amount of time in the workshop. So it really means to figure out what is important to you, like CPU usage, container memory, are the replica sets in a good shape, and so on, and use that to create your own dashboards, create your own overviews, which are really helpful when things are broken, or even like monitoring the deployed applications, and have a central overview of that. So it needs customizations, and it also needs onboarding, documentation, and everything else, because when someone new joins and you have a multitude of dashboards and something breaks, and like, yeah, I have no idea which signal I should be looking at, it really makes sense to also focus on, for example, on the golden signals and have error rates, for example, as a documented way to do incident management. because the goal should be to immediately see what's important during an incident with a lot of moving targets, a lot of things going on. Customers calling, you should be fixing it yesterday, and other teams are like depending on your service, and like it's like the world is on fire, and you shouldn't be stressed to like figure out, hey, is this metric actually showing what I'm expecting it to be, or maybe should I be looking at a different dashboard, or maybe doing my own PromQL queries. It's also helpful to, when you're doing something manually for the first time, like creating a PromQL query, either you create a panel or dashboard, or you document it in your handbook or knowledge base to have it available for future incidents. Avoid doing things twice and just have them documented. With regards to customization, if you want to modify kube-prometheus, you need to use JSONnet. So this is something to learn or look into, but it's really powerful. So I tried it myself, of adding more rules and creating my own dashboards within Grafana. You can monitor different namespaces. You can add your own applications. You can remove applications if you don't use them. And just to provide you an example, I'm not sure if you can read it in the stream, but you can just check it out on the slides, which are available. This is a way of, maybe can I zoom in here? Which I can just like, the JSONnet is, oh, it's actually linked in here. This is really like defining a dashboard, adding a template with the data source for Prometheus, which is configured in a different configuration, and then adding a panel which monitors the container memory RSS. And this is the Prometheus, the PromQL query, which is actually being executed. So this is something one can do to customize kube-prometheus and also create your own custom dashboards. The only thing which then is needed, like to modify the default configuration. Yeah, and we're talking a lot about monitoring and metrics, but there are like certain things like beyond metrics, because it's not just seeing what is going on in your Kubernetes cluster. There are like, you need more context, you need more insights. There are certain things really to keep in mind. And I know it's been a long workshop already, but there are interesting things to come. And I really don't want to rush through this, but to provide you some ideas. And we might be looking into 1 or 2 exercises, which are pretty advanced. So maybe you just watch me do them and practice on later on following the steps. But yeah, in the end, there are more than metrics. And this is like, we have metrics, we have logs and events in a Kubernetes cluster. We are thinking about tracing or traces. Additional things like application performance monitoring can also mean profiling your applications and seeing where you can optimize an application. So like a function is called 1,000 times, but actually it could be executed in parallel or just being optimized. Error tracking is also an event type, which comes to like thinking of, is this like observability? Well, it's a definition of different observability data types, so it can be, but observability is like providing the look above and looking into things you're probably not aware of yet. So think about unknown unknowns. Like you have a DNS latency in your cluster, which causes the deployments to sometimes fail, and the APIs don't resolve that often. So this is the reason why your customers cannot buy items immediately in a shop and sometimes see a 500 error. Probably you wouldn't be figuring this out by just using metrics and looking into the deployment states of your applications. Now, how can we like fix that and provide more data by default from a Kubernetes deployment? And this is potentially something which needs more work, especially because when we're coming to logs, there are like so many decisions, which makes it super hard to make a recommendation. And by no means this list is exhaustive or a recommendation for any vendor. It's just like providing some examples of saying, hey, you can either inspect the logs on your pods on the CLI, which works if you're trying to troubleshoot something, but oftentimes it's really needed to get a bigger view and collect the logs into a central log management solution using agents or using daemon sets or sidecar containers, which can be, for example, if you're planning to use a self-managed solution, maybe as an example, using Elastic and the beats as agents and collecting everything and then doing some source queries in Kibana. There are certain alternatives to that, for example, with Grafana Loki and Promptail, or just using FluentBit or FluentD as a sidecar and having a log management solution somewhere else, which then could be used, could be stored in the cloud, for example, as a SaaS, software as a service offering, which of course costs money. Oftentimes, some have a free tier, some have not. And the idea is like, what logs do you actually need? So like, is it important to have a log retention of 1 year just to see that all incidents happen and just to correlate some data? Or maybe it's just a live tailing, which could be like retention of 1 day to be capable of tracking incidents. So this is like really, or many things need to be decided. The other thing I want to bring to attention is tracing, which is like a trace is like a log, but with more context somehow. So it's like providing a duration of a start and an end time within a span. You can enrich it with metadata at your own pace. So like providing more context. This is using the Docker engine XYZ. This is like the deployment is using a library version or a dependency, or everything you already have available within the application context is something you can add. Now, the thing is, adding this by yourself needs knowledge about code instrumentation. So developers need to learn that. The other way of thinking about this is doing it in an automated fashion to like inspecting what is possible. And this is more easy with a virtual machine in Java rather than like doing it in a C++ code environment. But in the end, there are certain ways of achieving tracing, which can be helpful, especially in a distributed environment. And the idea is moving on from tracing to OpenTelemetry to provide a common or a general specification and framework which works beyond vendors to really like collect traces and have them stored in your own backend. So Jaeger, for example, can be used for traces. There are ways, or there are plans, or actually it's already there. So metrics, you can send metrics to OpenTelemetry and store them in Prometheus, for example. Logs will also be coming, and even more event types. So really like the idea is to define a specification which everyone can use and depend upon, rather than 3,000 different formats where it's super hard to really like pass them or use them or even like correlate metrics with traces, with logs, with even more data. You will be this in the past, this was this is still really complicated. Speaking of experience, and the idea is really like to combine this, and also to provide client libraries, which makes this easier to do code instrumentation and also provide auto-instrumentation. If you want to learn more, I would recommend like checking this out, like especially with code instrumentation. Focusing on traces in Kubernetes means, and this brings me to Kubernetes kind of observability. The components themselves can send traces. So there's like, I think this is a feature which is an alpha in 1.25 where the components can be enabled to send traces, just to get an idea of what is going on within the Kubernetes cluster itself. Or use app instrumentation with traces. So instrument code or use auto-instrumentation to send to a central OpenTelemetry collector store them in Jaeger or whatever other backend is useful, and then visualize, correlate, and alert based on traces similar to what is possible with metrics already. The reason, or an example for traces, if you imagine the Chrome Dev Console, where you can see like how long is an HTTP request going to the server, then it loads some JavaScript, then it loads some images, and why is it so slow? And this is like mimicking this a similar view within tracing to get to see how long certain operations take when an HTTP request is sent from the client to the server, to the MySQL or PostgreSQL or whatever backend, to a REST API backend, to something else, and even more like with a distributed environment to really get to see why things are slow, or maybe they are like using too many requests in the backend, which can be parallelized, and so on. Now, the thing I want to quickly try with you in this workshop, and this is something I tried last week for the first time myself, OpenTelemetry has a demo which allows you to deploy it in a Kubernetes cluster. You can also, if you're interested in learning more about this, use the OpenTelemetry operator, the Jaeger operator to deploy OpenTelemetry and Jaeger in production in your Kubernetes cluster. But the Helm chart is really like just to get an idea of how things are going. So the first thing we should be doing is, and it's marked as an exercise again, so it needs our attention to do something. We need to add the OpenTelemetry Helm chart. And oh, I already added that. Yeah. And I'm getting some warnings about my kubeconfig again. I need to fix that. And we want to install, just using what is there already. So it will deploy OpenTelemetry with Jaeger, and I think there are also some metrics inside, but the idea is really like to have a web application available, a SOC. No, it's not SOC shop. It's a shop where we can do some shopping and then inspect how the backend requests and so on are going forward. Now, in order to access the demo, we will be using some port forwarding commands, and this is something we can actually like copy paste. I would recommend doing them in a new terminal or new tab, depending on how you use it. And this is the demo front end. And we also will be using the Jaeger UI, which is used for visualizing the traces. So the front-end UI is the shop, the demo application. The Jaeger UI is the tracing front-end analysis application, and locust, I think, is it's a load generator, which we probably don't need, but let's see. Yeah, so going much longer than I actually planned, but I think it's worth showing rather than reading. So if you do agree, let me know in the chat. If you are exhausted and say, hey, I need a break, it's also totally fine. So you can just watch me do it. And later on, the last thing I really want to dive in is chaos engineering, at least for a little bit. But now we want to have a look into OpenTelemetry. So one thing we can quickly do is open the front end. And this is this is a demo shop. So we can go shopping. We can try to buy something. We can 10 buy, 10 add to cart. It didn't break yet. There is a logo, okay. So this is kind of like a shopping application. And this is one of the microservices demo, which works nicely because you have a front end, you have we have certain backend communication available. You have like a workflow from I need to go shopping, I'm clicking something, I'm adding something to the cart. It can be slow sometimes. And like I want to do I can place my order. No, it doesn't work. Okay. Maybe, yeah, the thing is really like having certain, oh, interesting. I had quite some delay. And this is something you potentially will be seeing within the Jaeger UI now. So if we open up the Jaeger UI, which we will be seeing for the first time now, I think I probably need to zoom in a bit. So the idea of the Jaeger UI is you have different services. And this is something that traces and the spans can define by themselves. But for our example is like we have the front end. And we want to see the latest traces. Potentially making it a little smaller again. So we can see this is like the load generator. The load generator, for example. So there was one error within that trace. And the cool thing is we can see what actually happened in there, and the checkout service for some reason had an error, and it has logs. Okay, this generated an error. One of the ideas is next to like analyzing what took the thing so long, we can compare traces. This was just this one and this one. And then seeing like this didn't work so well, but these items did. Oh, I can actually zoom in. I didn't know that with two fingers on the trackpad. But yeah, the general idea is that you get to see something which, for example, took a lot of time. So this is like a trace which took longer than others, and it also allows to determine certain anomalies of traces. And potentially, yeah, we can immediately like model that. Jaeger is like just one UI you can be using for traces, but just to get started, it's super helpful. And when you have applications deployed which emit traces to OpenTelemetry, for example, you can immediately like store them with the configuration in Jaeger and have them available. Or if you're not using Jaeger as a front end, you could be using something else, which might be integrated into your cloud monitoring service, or using a different vendor or something else. So it's really about like collecting traces, sending them to OpenTelemetry, storing them in Jaeger, or storing them in a different backend, and have them like queryable from different vendors again. Now, as a discussion point, why should I be using traces, or why are traces more interesting than logs? Like, this is my personal opinion, because we have distributed microservices. So metrics won't tell you that the Redis caching for this one load balancer route is slow for some reason, or there might be an outage or something else. So you really need to like look into the execution path of a client request reaching all the different things. And it might not be visible in a pod log actually. So even if you're seeing an error in the logs, what is the root cause of the problem? So it's really like getting a view on top, like observing things and not actively monitoring things. Especially when it has an external impact. So if it's like using an internal deployment, or using some internal things where certain delays are expected and okay because they can be fixed, and telling each other in a Slack channel and say, hey, please look into that, open an issue. But if it has like a customer facing incident, this can be really like a problem, because if users are seeing one location sees a 500 error on your SaaS service and another location does not, how to correlate that data and getting an idea, for example, together with error tracking, what is actually going wrong. The other thing is, when you're instrumenting your code with tracing, you can provide, for example, software versions or library versions, which you already know about, or specific dependencies, and enrich the traces and the spans with that metadata in order to improve the ways how to troubleshoot things. Because as you can see, as you saw in a short demo before, there is a way to provide logs to the spans. So you can also like enrich the spans with additional logging and say, hey, this trace was doing an SQL query and it failed because of this, or the transaction took longer than expected because of whatever. But this is like going more into application and distributed architectures rather than Kubernetes now. So not diving too deep into that, but it's like it's providing a way to really do like whitebox, providing whitebox insights. And the other idea is, like, as a developer, you can make your life easier, because if you need to do later debugging and try to analyze why things are not working, or maybe doing a blind guess and doing a hot fix, which gets deployed to production and it doesn't work for some reason, and doing it again and again and again, can lead to developer burnout or just burnout. So it's like, it's one way, seeing a value in metrics, seeing a value in traces, and getting immediate feedback, maybe in a staging environment. Now, what is next for this? Reviewing your code should be one of the tasks, looking into how to instrument the code with OpenTelemetry, but also finding a way to maybe doing auto-instrumentation. Focus on traces first with OpenTelemetry, because the collector can receive more types. So like metrics, logs, and so on are either in stable or in draft or in beta, and evaluate how tracing can help specifically within an SRE or DevOps workflow, be it in runbooks, be it in incident management documentation, be it in I'm sending an alert and something is going on. Now, traveling back in time to the logs again, and I thought of like creating an exercise for it, but I couldn't find any which is easy to show, because it needs a deployment of specific log management vendor. It could be like do something, but we need to run either in Kubernetes, maybe Elastic Cloud or Grafana Loki or something, or use a sidecar, which then sends the data to different platforms, which can be either in SaaS or self-managed. So just to give you some ideas around like Logs.io, Datadog, Dynatrace, Splunk, Honeycomb, Elastic, and OpenSearch, Graylog, Grafana Loki, and so on. So this is not a vendor pitch, but just to like provide you some ideas. The vendor websites, in my experience, often overwhelming when it comes to observability, like everything. Figure out what you need, and don't feel overwhelmed by all the different terms and types and things. Sometimes it can be a good idea to go the full vendor login and say, okay, I'm achieving observability using this method now. I'm evaluating things, but really like follow the evaluation. So use things step by step. And if you say, well, it's nice that I get to see all the features from vendor XYZ, but in the end, I really want to build it myself and maintain my own Prometheus instance and OpenTelemetry and whatnot. This works perfectly fine. Yeah, in the end, logs is really super. In my experience, it needs evaluation as well, similar to all the SaaS platforms which are available, and their observability and event types don't stop there, because I mentioned continuous profiling before. This can provide application performance insights, generates new data, and generates new ideas. So if a profiling value or profiling data, maybe I want to do alerting with it. Maybe I also want to define service level objectives on profiling data, because I'm treating it as a way similar to tracing and metrics. Many ideas. Which brings me to performance and scaling ideas, which I'm not really sure about. Like, it's hard to make a direct recommendation, provide an example of you should be doing this for the fastest and for the most reliable and for the cheapest architecture you want to expect out there. So I can just provide you some pointers where you should be looking at, similar to like metrics. How long do you need the granularity of 5 minutes for a metric being stored? It doesn't need to be 5 years unless you have a lot of money, which allows you to store that store the metrics that long term. And also, like, it's a problem of querying a large data set. So in the end, it needs data retention and compactation. This is the term used in Prometheus, so that you, for example, have a granularity of 1 hour for metrics which are older than a month or a week or something, and everything else is like more granular. This really depends on the storage requirements, on the compliance requirements, on certain things in your environment. But probably in the beginning, you shouldn't be caring about it, but long term or putting it in production, this might need evaluation and also like having a look inside. Similar goes to traces, where data is being sampled. So you don't get to see everything, but only a sample of certain things. And there are certain like providers saying, hey, we are not sampling anything. We're providing you with the raw data you can like want to use. But this is also like a calculation on pricing and other things you should be looking at. How long do you need traces? Similar to like deleting the data you don't need for debugging. For logs, it follows the same approach with looking into archiving things. So I don't need the logs from 1 year ago for a specific pod or something which doesn't exist anymore. So at what time frame do you need the data for debugging an incident? Or maybe doing like a post-mortem root cause analysis 1 month later on. Think about like if you're working in a company which has compliance requirements, so to archive everything on a magnet tape, this is different to like an environment where you're working on your own and just need the data of the past week, for example. And everything else is like there is a process, document everything, document incident management, have runbooks, and so on. For storage in the long term, just for Prometheus metrics, you can look into Thanos or Cortex, which provide high availability and long-term storage, and also a certain way of like doing aggregated queries over multiple nodes, which probably will be needed. Otherwise, it potentially makes sense to look into certain ways of using a SaaS offering or something else. The other discussion point around resources and scaling can be like, you've seen that the deployment within the cluster takes additional resources. So figure out how much cost the monitoring or the observability tooling and events and storage itself can add to the operational cost. So like using something like OpenCost or InfraCost to help estimate the costs, and also like for persistent volumes, plan ahead. So like how much storage for metrics, traces, and logs will you need, or how to like manage that, because in having something in memory, something which is, for example, I think the OpenTelemetry demo does it with Jaeger. this works fine, but what if you restart something, it starts again? So you need to think about persistent volumes as well. And the other thing is like maintenance, like I mentioned before, manage everything yourself or have something, an agent or remote write with Prometheus, send it to a SaaS platform, which operates everything and abstracts that away. So this is like really, this is like the business decision later on, but you need to keep that in mind. From a scaling perspective, if you're thinking distributed, and this is probably something you might have seen at KubeCon and different other reports and large scale environments, a multi-cluster approach. So like have a Prometheus stack in each cluster, or use something else like sending the data out of the cluster to a central Prometheus instance. So like also similar to which data can we share with which type of user. So for example, providing Kubernetes service to customers, which observability data should they be seeing? So something like restricted permissions, RBACs, single sign-on, policies, restrictions on the data backend so that everyone can only see their tenant and not everything else, which can be leaking security and sensitive details. So like a central observability with SaaS platforms can also be an idea. Prometheus remote write is one way sending metrics out of your cluster. Could also be using an agent, like Datadog has an agent for sending that to SaaS platform. Other vendors have agents or sidecars, daemon sets and whatnot. This is all something to consider in large-scale environments, going beyond the scope of a single Kubernetes cluster. This needs discussion. This needs, I would recommend going to events and meetups and discussing with the wider community to get an idea. And also like, and this is just an example from a previous workshop, looking into how others are doing it. So like our SRE teams at GitLab have documentation, have runbooks, have dashboards, or like how dashboards are being built and enriched with specific URLs for context, for alerts. What are like the key metrics to observe, like the error rates as a golden signal and others, and how to do scaling, for example. So my colleague Andrew Newdigate did a talk at KubeCon, I think last year, how we are dealing with metrics at scale on gitlab.com. I would recommend watching the talk to get more insights, and also follow the links on the slide to really like get an idea how it's being done in our environment at GitLab, but also getting an idea of like how it's done at Netflix, Uber, and other vendors who have like the problem of scaling things. Yeah, and since I'm taking all the time I need today, I was thinking of having 4 hours of workshop material. Potentially I'm going a little bit too fast, but I'm hoping still that some folks are following along. And Saiyam is not falling asleep, because I know it's late for you. Sorry about that. The last thing, or one of the last things I want to dive into, is observability and chaos engineering, because this also touches a thing I've been like trying in my recent talks at KubeCon and Container Days, like finding a way to break things, because figuring out how your alerts are working is probably hard if you do it manually. So if you want to simulate an incident, you can try to fail DNS, you can try to break your network, you can try different things, but oftentimes you really want to define it in a time frame. You want to fail certain services, and then you want to measure the impact and the results, do a retrospective, and see it as a way to improve and iterate your observability and, for example, alerting rules and service level objectives. And at a certain point, it also makes sense not to only break production and see how it behaves, but, for example, integrate it into staging environment deployments from CI/CD workflows, and see how the application behaves. So, for example, that you as a developer get immediate feedback in a merge request or pull request, rather than the bug or regression hits production and you're being woken up at 3 a.m. in the morning. If you, on the other hand, could have seen it in a merge request and it couldn't be merged. So within the cloud native environment with Kubernetes, we do have a great way of, like, there are certain projects which create a chaos framework where you can define experiments inside, and they also provide instrumentation SDKs. So like adding chaos engineering to your Kubernetes cluster. Again, costs some resources, but it's worth trying out. One of the things you can try out, and this is potentially not safe for work, but I found it pretty funny, to use kubedoom to kill some ports using VNC attached and so on, which allows you to break ports in production and see how the application is actually behaving in the Kubernetes cluster. Now, on a more serious note, one of the toolings or one of the frameworks I've been using in the past months is Chaos Mesh. The other one is Litmus Chaos, which are CNCF projects, which allow you to create chaos experiments or run chaos experiments either once or on a continuous basis and fail services. And by services, I mean, like, you can kill ports, you can create error rates in the network, so trigger the golden signals and see if your alerts are behaving correctly. You can slow down or abort certain HTTP requests, or even inspect the headers and provide different payloads. Time is one thing which you can also break, which is kind of funny, if probably remembering the old times when time is off and it's then in sync again, and the application doesn't know how to jump between time, and then it's either running in an endless loop and crashing, or it's leaking memory. DNS is like one of my favorites, especially because of my nickname probably. But yeah, failing DNS, either failing the resolver of DNS or just providing a different IP address and see what the application is doing. This can be quite interesting to actually do. And one of the things I really like about Chaos Mesh is that you can define a custom resource definition, just like the Kubernetes YAML format, and it allows you to break something. And in this example, it just creates pod chaos for a label selector, which targets a specifically deployed app and breaks that. And we can see that Kubernetes is healing itself. So it's actually like crash loopback off in this current state. But it's one of the ways to be using Chaos Mesh. The other thing I tried for KubeCon and some other talks this year was my own application. And one experiment or one problem I had in my, I think it's now 20 years of developer experience, I was developing an application which only leaked memory when a DNS was failing. But I couldn't reproduce the problem on my machine because I didn't know that DNS was failing. So I wrote a small application, which is linked in this example over here. And you don't need to understand C++ to really follow along. The idea is really to say, hey, I do have an endless loop. I'm trying to resolve a host name. And when it fails or when the result is empty, I'm handling an error. And otherwise, I'm just continuing. And just to simulate an application receiving something, I'm creating a buffer, which is 1 megabytes. And I'm sleeping 1 second. So potentially everything should be working fine. But there's a programming error inside. So this one, it just handles the error, which is defined over here, but it doesn't free the buffer. In C++, you need to free a buffer which you allocated with new, later on with delete. So in this scenario, this application leaks memory only when DNS is failing and 1 megabytes every second. So this is a perfect example for showing how an application problem can lead to memory leaks and how to really monitor that with Prometheus and use chaos engineering to trigger that failure. So just to do that quickly, we will be installing, and you can just follow me along with that and practice this later on, because this is specifically the configuration in Civo Cloud right now to being able to access the container socket. I will be just copy pasting the commands as a quick exercise. Here. Actually, my Kubernetes cluster is eating quite some resources now. Did it work? Yeah, sometimes my terminal isn't so user-friendly. Okay, this is deploying Chaos Mesh now. While it is deploying something, we can also open up Chaos Mesh for a second. And you can install it using Helm charts. I think there is, not sure if there's a manual install available. But yeah, the idea is to really like deploy Chaos Mesh and being able to create your own experiments. And it's a cloud native community project, which I really like, because this ensures that it's in a good community foundation and everyone can contribute. So it's open source, it's Apache licensed, and it doesn't go away that easily. Now, the other thing is it needs port forwarding. So the front end is using, okay, we have created the ports already, or they are creating. It has a front end which allows us to create some experiments. So the idea now is, in this small demo, small exercise, deploying an application, create some alerting rules, and then inject some chaos with DNS and see that the memory is going up. This is actually like my KubeCon demo, but we are doing it live now in a workshop. Or KubeCon Europe, because KubeCon North America is not there yet. So this is like Chaos Mesh, and the dashboard invites us to create workflows, schedules, experiments. And because I want to create something which runs on a continuous basis, I'm creating a new schedule. So I can just click here, and then I have like an interface, what I want to do. But but the thing which I really love about this thing is, or this project is, you can just upload a YAML configuration, which we can do in a bit. Oh, I'm moving too fast. First, before we can create that experiment, actually, we want to deploy the application which leaks memory. So we will be deploying, just to inspect this one, we will be deploying an application multiple times. So this one tries to resolve O11 y.love. This one is cncf.io. This one gitlab.com. And specifically for this workshop, we're also trying kubesimplify.com. So typically this should be working fine when we deploy it now. So going over here and let's handle the port forwarding later on in a different tab. First off, we want to deploy this now. And if I recall that correctly, we should have this in the default namespace. Yeah. So we were fast enough. It's creating the things. And the other thing we want to quickly deploy, and now you can see that the Prometheus rule will be working as a custom resource definition. This is a Prometheus alert for the container memory, specifically for this container. And when it's more than 10 megabytes, it will alert. So this is something we also want to deploy just like this into the Kubernetes cluster right now. And it should be just fine. Essentially making the Kubernetes Observability workshop into a Kubernetes Observability and Chaos Engineering workshop now, but I really like to show this because I also had a lot of fun building out the demo for my talks with that. So Chaos Mesh is really awesome, and Prometheus as well. Now, coming back to Chaos Mesh, we can, and I'm doing that in GitHub somewhere, we can add port forwarding. And going back to the Chaos Mesh tab, yeah, we want to actually create this DNS schedule experiment, and I will explain it in a bit. I'm just copy pasting this one because I want to create it by YAML. So I don't want to click around the UI, but I can like create this one. And the idea is to really like schedule a chaos demo of the type DNS chaos. The action is error. So we really want to fail DNS and not randomly do something. And the patterns, I can match specific domains. So I can fail everything, okay. But if I really want to test my service or my specific other things, I can fail specific domains. I can also use the namespace selector, which should be using the namespace default. And I can also define the duration. Now, if I click submit, the front end allows me to verify what has been selected. So it's an additional verification of, hey, maybe I want to modify this one, or maybe add some namespace selectors or something else, because probably I'm affecting too many services right now, but it's totally fine. For our demo case right now, we should be seeing the kubesimplify service, which will be our demo target. So I'm clicking submit over here and submit for the second one. Everything is ready, and I can click submit, and now everything is like running. So can inspect it again. Currently, there are no events being found, but the schedule is creating chaos experiments now. And the idea is to really like inspect the logs for the, going back over here, the deployment for the DNS leaker service kubesimplify. So we're getting host results, and at some point we shouldn't be getting them. And as you can see, there are 4 IP addresses actually attached to kubesimplify.com. And you can ignore the port. This is just needed by the application itself. I think there should be at some point, we should be having some errors. Potentially, oh, this is like the schedule which is running. Failed to call webhook. Oh, interesting. Potentially it's again the demo gods which are failing me. MDNS. Start again. It should create a new object, which then runs as experiment, which is injected. But for some reason, it throws an error. Okay. Let's see. Yeah, this is, don't mind the errors in the web interface. I was actually like planning for this. So now DNS is like injecting a failure, and this is not authoritative. So it's kind of intercepting the DNS traffic for the application. And now, since this has been running, we should also be able to see that the memory is going up. So we can query, or we can use Prometheus, which should be over here, to query the container memory RSS. Now this oops, no, was the wrong copy paste. Sometimes copy paste doesn't work in this browser. Okay, we want to execute this, and we want to see a graph. Oh, yeah, and we can see that the memory is going up at the time we were starting with our chaos experiments. So the highest one, okay, this is the GitLab one, this is the CNCF one, this is O11Y, this is, kubesimplify currently consumes a little bit of memory, so it's 30 megabytes. If this stays over 10 megabytes of memory usage, too many metrics today, sorry, we could potentially, we should be seeing an alert. Now, in order to be checking this, I will be closing some of the many tabs I've opened and checking back into our alert manager, which I think, yeah, it's in the namespace default. And we, for example, can click here to have an applied filter for it. And for example, if I want to see specifically the alerts for the host resolution for kubesimplify, I can check for that. So in the end, this triggers a memory leak for the deployed applications, but only when DNS resolution is failing. And the reason why it fails currently is because we're using Chaos Mesh to inject the DNS failure. I hope this isn't like too much mind-blowing right now, but this is one of the ways I found it really reliable to create some chaos inside a Kubernetes cluster and see which alerts are actually being triggered if the applications behave the right way, and also like have a way to being sensitive on these deployment errors before they're actually hitting production and affecting other teams and creating many alerts and other things, but instead having a way to really have a defined way of testing things. I wouldn't recommend like what is next doing all these things all the time. So potentially analyzing what which problems were caused by chaos engineering. Maybe the alert counts were too much again, and you need grouping or additional context in alerts, or even like refine the focus in dashboards because the alerts didn't provide as much context as needed, or even reduce the amount of visible data. Yeah, the other thing is like potentially, and I'm not sure how this, not sure if this like is applicable already, but using chaos engineering for test for traces again, like to get an idea of, hey, the HTTP request is so slow, or the client-side request is so slow. Use chaos experiments like for stress testing, for CPU and memory stress testing, as well as slow HTTP requests. I actually made it work a while ago. This is also available for you to test if you want to. And just to conclude with some ideas around correlating metrics with traces. This is called exemplars if you link metrics with traces, or even being able to create metrics from traces using OpenTelemetry, which is called aggregated trace metrics. Also something to keep in mind, to keep an eye out for, especially with regards to current developments, how OpenTelemetry will be advancing in the future and so on. And similar to like, how does it play well with chaos engineering and chaos mesh and other tools. Yeah, and just to like sum everything up or give you some additional ideas, because life is a learning exercise or learning adventure. Like what could be like future observability with regards to Kubernetes and other tooling? Like you probably have heard about eBPF, which is a different way of collecting metrics and collecting values on the kernel level of the operating system, basically. So like not being required to instrument your code, but instead collect specific syscalls and events on the kernel level, also to provide some observability and security. So something around like Cilium, Falco, Parker, and Tracy for different use cases, especially for the reason why how does it like fit into Kubernetes observability with Prometheus metrics and everything we've learned thus far. It can be a way, and I'm seeing that pattern with quite a few tools and startups to provide auto-instrumentation for specific languages, because code instrumentation is something you need to learn, and it might be easier to use auto-instrumentation with new technology nobody understands yet, but it's a way to get to results pretty fast, and then we can like see what other things eBPF is capable of doing. This is something I didn't really prepare for the workshop today, but I wanted to give you an outlook or provide you some insights into maybe trying Cilium Tetragon and also Pixie for this kind of observability within Kubernetes, more of an idea of a developer's perspective, or seeing it as a way to also apply security policies to prevent things from happening within Kubernetes. But this, like, again, this goes way beyond what I want to tell you today, but I would really encourage you to watch the recordings from our Everyone Can Contribute Cafe meetup, or join future sessions of the meetup and try it out yourself. Yeah, as you can see, to-do advanced topic, didn't really figure it out yet. The other thing around service level objectives and Prometheus, maybe you want to look into quality gates with Keptn, which can be used in that regard to prevent certain things from happening when the service level objectives are failing. Also a thing I would highly recommend trying out by yourselves. And last but not least, obviously security should be on the first front. But I really want to mention it, like Kubernetes security monitoring and getting an idea needs to happen before the deployment. So like think about CI/CD security scanning, cluster image scanning, Kyverno policies, open policy agent, and so on. And the other thing is like think about Prometheus hardening with TLS and basic auth, with the cluster communication using MTLS and so on. Where I totally recommend getting the book Hacking Kubernetes from Andrew Martin and Michael Hausenblas, specifically also with like the security defaults may need improvements in a default Kubernetes deployment. So for example, you could be using observability patterns and chaos engineering experiments for pen testing in your Kubernetes cluster and apply those things. Again, many things to read and learn, but it's your adventure with all the things heard today and probably seen today. The last thing I want to keep at the top of your head is think about how you can instrument your code and make your life easier, either with Prometheus or with OpenTelemetry or with everything else. We might be seeing future workshops in that regard. Yeah, and many more resources. I do have I've created a knowledge base which I called O11y.love, observability.love. Potentially check this one out. And if you want to learn about more of my journey, my findings around Kubernetes, cloud native, observability, subscribe to my newsletter, opsindev.news, which I currently write on a monthly basis. Yeah, just let me know how things are going. This is now like, thanks for your attention, and hopefully there are no questions. No, just kidding. thanks, Saiyam, for the possibility to do the workshop today. So I really like telling my stories, engaging with you, and hopefully you learn a lot today. Let me know how things go, and I'm happy to help. And yeah, I'm talking too much. Thanks.
No, that was amazing workshop, Michael. So actually, when we were starting, just to let you all know, Michael asked, like, what's the regular time of the workshops? He said, I have prepared for 1 to 2 hours, but it might go a little bit up. I said, yeah, it's fine, as long as the content is dope and you are going with the flow. People will be here to stay, and people are here. They are learning till the end. So it's amazing, and we are like close to 3.5 hours, and Michael has been speaking continuously, so we have given him just a bit of rest for now. So thank you, Michael, for this amazing presentation. First, great exercises, great demos that you showcased, great live kind of debugging whenever it was necessary, and you fixed the issues, showed us the alerts, and seeing those coming in at that point of time is very good. I think people should take a lot of things from this particular workshop, like playing with Prometheus queries, Grafana dashboards, setting up that, writing your own Grafana dashboards, alerting, writing your alerts, black box exporter, instrumenting the application, how to get those alerts in Prometheus, how to do chaos engineering and alerts. So I think there are many parts to this particular workshop that you can actually go back, break it down, and then revisit and try to do it at your own pace. So it can be overwhelming at first, if you have heard like everything. There might be a lot of new terminologies. I always say for Kubernetes as well, when you learn Kubernetes, there's a lot of new terminology that you have to like take hold of. It's not easy. Same as in mathematics, when you did trigonometry, there's a lot of terminologies that you have to grasp. So all those are in the similar lines. And for this workshop as well, go back, revise this workshop, do it in parts, do the complete demos. You can use any Kubernetes cluster or CO Kubernetes, whatever you feel comfortable with, and install kube-state-metrics, install the metric server, see what all stuff you can do, see how you can instrument. Like in the previous slide, Michael mentioned, you can instrument your own application. There are many aspects which are covered, and I think this presentation will be available to the people, right, Michael? This is not going soon away.
No, this is public information. And the thing I will be doing after the workshop, when like the YouTube video is available and we combine all the resources, I will be also adding them as a resource to the GitLab Developer Evangelism Handbook. So just to like, cannot talk today anymore, but we do have like our own handbook. And one of the things, and this needs projects, I've been doing kind of a Kubernetes monitoring workshop in the past. So all the workshops and everything I'm doing or our team is doing is like linked in this section. And at somewhere at the bottom, there is like, yeah, that was the first iteration of this workshop. So when everything is like done, I will be adding it here and also making it available on, yeah, basically everywhere. You will be seeing it also here then, where I'm like sharing
Awesome.
what I'm talking about. And you might see some overlaps with my talks, and this is intended because I love to repurpose everything.
Can you share that link, that GitLab projects link, so that I can share that with people as well?
Yeah, I assume you have shared the slides already with folks.
Yes,
So
yes, I
yeah,
have.
I will share them with you in the chat so you can copy it over to YouTube. And also
And it's done.
this one, it's just like my website has all my talks and everything you probably want to know. If you want to see my background and a little more other lights, this is my workspace. If you're
Fancy.
planning on getting some Lego for your background as well. Yeah, and let
Cool.
me know
I saw
on
a comment.
social media.
Yep,
Sorry?
I saw one comment. That's a very nice Lego in your background. So there was one comment that came in.
Yeah, the thing is, or just a short story around the Millennium Falcon. This was a gift from the monitoring community a while ago. So I did a lot of community support and engagement and being a maintainer, and some friends granted me that as a gift. And I was like,
Wow.
oh, wow. So I tried to make it really like putting it the best way and always having it in my background as a great memory. And also, yeah, it's an icebreaker in every conversation as well.
Nice. So, everyone, I hope you really enjoyed this workshop. I enjoyed this workshop. I was here the whole time, and I did many of the exercises as well. So, I hope you were able to do at least 50-60% of the exercises, and you'll go back and do the rest of it. You follow Michael on Twitter. He's very active over there, sharing all his learnings, all the new cool tools that he found. He find in the CNCF ecosystem, observability ecosystem. So make sure to follow him. Also tag all your learnings, like all the screenshots, Grafana dashboards, with him, so that he can see those, what all stuff you have done during the workshop, what are learnings you have taken away from this particular workshops. So do that. Tag me as well, so that we both can retweet that, like that, and
Yeah.
we all can share good stuff. So yeah, here is his Twitter handle as well. So just
Yeah, the other thing I want to mention is I will be in Detroit at KubeCon. So if you are traveling to Detroit, I would love to meet in person. Other than that, I think I will be mostly in Germany this time. But let me know if there is like a meetup in my area, or maybe you're around, so we can do something together in person, or just catch up for a follow-up coffee chat, or let me know on Twitter publicly, or even on LinkedIn.
Yep, Michael is very approachable, so I think you can ask him questions. Don't buzz him too much. You can ask him.
I would say ping me publicly on Twitter. My
Yes.
DMs are like chaos, so it's chaos engineering in my DMs. I prefer working in public. So if you're able to ask in public, do it in public, and we can loop in more folks to contribute.
Awesome. So thank you, Michael. If you are at KubeCon, feel free to reach out, Michael. And if you are at HashiConf, I'll be there at HashiConf, and also Dubai GITEX. Both the events, I'll be there. Unfortunately, I won't be there at KubeCon because I will be at two events in October already. So third one, I won't be able to make it to the third one. But yeah. It will be nice meeting Michael at some of the other events coming in future. Yeah, thank you so much for this workshop. Make sure to follow Cube Simplify, all the next set of workshops. I don't know when the next one is. I think there is one in October, and after that I haven't planned, to be honest. But yeah, streaming keeps on continues. The videos will keep coming on, and the workshops are gold, so you can watch all the Cube Simplify workshops. And just if you want to learn something, the resources are available, people are reachable. So do not let the resources be the barriers to your learnings. If you want to learn something which is not there at all, reach out and we'll try to fix that. And thank you again, Michael, for spending great amount of time, great amount of knowledge, and this amazing session with all of us. And thank you all who stayed till the end. With that, I leave you all to the rest of the day's night. So bye, everyone.
Bye. Thanks for having me.